I'm very happy to introduce our first speaker today from Brevis. Her name is Wanli, and please welcome her to come up here and present.
Hey guys, good morning. Thank you for being patient with me. There's some traffic on the road, and so I know the slide says Michael, but my name is Wanli. So I'm here today to basically introduce to you a very cool concept that you have probably heard of, but might not have the chance to dive deep into, which is basically how to scale Ethereum and also other decentralized applications using zero knowledge primitives. So my topic is 100 times Ethereum L1, the ZK path to infinite compute. Maybe I can start from looking back to when we first started. So blockchains were introduced or designed as world computers, but the reality has been that it cannot run faster than a single server. So it doesn't really matches our expectations for how computers should perform. The reason for that is because of the gas cost for sure. So it's extremely expensive to run very complex computation on chain. And I'll explain what that means using this example. So you probably are very familiar with like VIP loyalty programs in centralized exchanges where basically the more volume you trade, the better discounts you're going to get. However, like for a long time, we haven't been seeing any similar programs on chain. So we're not seeing like a VIP loyalty program that basically tracks your historical performance or historical volume on DEXs so that you can get maybe a rebate or discounts for your future trades. The reason for that is that basically if you're trying to implement everything for data retrieval, like basically all of the transactions you have completed for that DEX, and also you try to aggregate the volume data directly in smart contracts, that would mean a lot of hours of computation and a lot of cost in gas. A very simple data point is if you are trying to aggregate 10,000 trades for maybe 30 million in volume for the past 30 days to maybe prove that to Uniswap or PancakeSwap so that you can get a 50% trading fee discount or rebate, that would cost you 8 hours on chain and $40,000 in gas fees. So there hasn't been any way to get trust-free access and computation on historical on-chain data. And that has been the reality we have been facing with. So, but like the reason why blockchain has been smoothly running is because we're like running a lot simpler computation on chain. For example, consensus today is built on simple computing. For example, if Alice is trying to prove like 142 times 121, let's use that as an analogy for consensus, like the level of compute for consensus, then the on-chain compute power used probably is this level, which is the orange here. And Alice says to Bob might be another validator or maybe a set of validators that I have this result based on this computation, this calculation. And how does Bob ensure that the result they're getting is correct? They basically need to do the compute all over again from the scratch. So basically for validation to happen, for verification to happen, there is this recomputation process that needs to be done. So we see that like blockchain has been using this equation for recomputation. You need to do a verification. I mean, for verification, you'll need to do recomputation to ensure the correctness of the result. But that shouldn't be the case for complex logic, for like data dynamic features that relies upon large volumes and dynamic data feeds. For example, if you're trying to build the VIP loyalty feature that I just mentioned, you probably will need to process 1 million times the amount of compute compared to a simple multiplication. So in that sense, we're trying to see if there can be a new paradigm that would allow you to do verifiable computing without compromising trust. So you are still relying on the trust assumptions of Ethereum or other EVM chains or other consensus models. But at the same time, we'll systematically and holistically minimize the cost for the network. And how it should be done from our perspective is that definitely you still need to have this compute happen. But on top of that, we want to, like on top of the orange compute resources that you use, we want to also utilize a ZK primitive that would do another layer of compute to generate a proof that goes with the result. So basically what Alice would send to Bob or the rest of the validator set is not only the result of the multiplication, but also the proof, so that on the validator's end or on the verifier's end, because like we also face with DApp features or DApp needs that would also want to verify a result in smart contracts, they would only need to verify the simple proof, no matter how complex the underlying computation is. So this is like what we call maybe a math magic, because all of this is ensured by the underlying cryptographic proof with zero knowledge. So we're using this paradigm to basically decouple computation from verification, as you can see. And you can basically tell from this like compute resource differences on the left side and on the right side. So on the left side, the computation has some additional resources taken. The blue part is the new computation needed for the proof to be generated. But on the right side, the green part is like a lot less compared to if you do the entire computation from scratch again to generate the result yourself as a validator or verifier. So like combined for the entire system, for the entire network, it would mean a lot less resource consumed. And this applies to a lot of other scenarios, like, for example, if you are trying to prove the correctness or authenticity or validity of the output of a large language model, you want to make sure that it's functioning as it promoted, then this sounds like it would consume a lot of compute resources, which it does. But on the verification end, because of the characteristics of zero knowledge proofs, you will be faced with a constant proving cost or verification cost on chain. You're just taking like a constant sized proof on chain to verify, and so that smart contracts or end users can directly use the results without like trust. So what we're seeing is we at Brevis have built a primitive or a solution combining zero knowledge proofs and also some system optimizations, so that we're still like respecting blockchain as the glue point of verifiable off-chain computation. But we are having blockchain or dApps or users to offload complex computation that relies heavily on data to our off-chain engine Brevis, so that Brevis will do the computation and generate a result and the ZK proof back on chain for the end users. And it's not purely theoretical. Actually, in production, there are a lot of different usages for zero knowledge proofs using Brevis already. So we're working with, you can see a lot of different verticals, and I'm gonna get to like some very typical use cases of how Brevis is implemented, is integrated in these protocols. But you can see a lot of this like high profile top protocols in their each vertical are already using zero knowledge proof to implement very data-centric, user-centric features. So before I get into the use cases, I want to kind of give you an overview of how the Brevis system looks like. So we have a three-layer tech stack, and on the bottom, there is this proving network that basically matches resources with needs in a decentralized way. And in the middle, there is this core layer of a Pico ZK VM, the zero knowledge virtual machine, that basically is built as a general purpose VM that meets all kinds of application needs. And on top of it are ZK coprocessors that are app specific, they are domain specific, and optimized for performance for like different specific use cases. So Pico, the core layer of Brevis, the zero knowledge VM, is built on top of the RISC-V instruction set. And we also have on top of that precompiled functions that are like very common crypto primitives, including Ketchak, SHA-2, Poseidon, etc. And what's nice about using Pico is that you don't really need to be a math or cryptography PhD to know how to write ZK circuits so that you can utilize zero-knowledge proofs. But instead, if you already know Rust, that would be perfect because the entire Pico stack is written in Rust, and you can just simply port any existing logic into ZK circuits using Rust. So for example, here is a simple code snippet for how to compute Fibonacci numbers using Rust, and it's like very straightforward, as you can see. And on the performance side, so aside from like proving app logic, we're also facilitating Ethereum's like grand picture, which you probably have already learned from crypto Twitter, that Ethereum is transitioning into a ZK-proved consensus model. So we are like a pushing force, a propelling force in that initiative. And in fact, we're the top performing zero-knowledge VM right now on that front. So we have achieved basically proving 99.6% Ethereum blocks under 12 seconds. And like if you a developer, you definitely would know the meaning of like proving under 12 seconds. That's basically the slot time for block generations. And for as a data point, for proving 45 million gas blocks, the average latency we are seeing is 6.9 seconds, which is like basically the benchmark right now in the space established by Pico, by Brevis. And compared to the second best performer, we are like 71% faster. And there is also this like public goods project created by, led by the Ethereum Foundation called ETH Proofs, where they list all of the real-time proving ZK VMs that are like actively building and competing in the space. And you can also see the benchmarks that I just mentioned, Pico reaching 6.9 average proof time and listed as the top. So we have noticed that Ethereum scaling has become a pure money problem. And how Pico is approaching this, like so basically how we are approaching real-time proving to help with the Ethereum transition into ZK proof-based consensus model, is that we're taking a divide and conquer approach using subblocks. So we're not just directly computing over entire blocks, but instead we divide each block into 7 subblocks and prove them on 7 GPU submachines. Then we would aggregate them on the 8th machine, and that's how we achieved our performance. So into the design thinking of how we visualize how Pico should be built, like we definitely were faced with 2 directions, and that's probably the common trade-offs any ZK VMs would be faced with. On the one hand, you would have for performance, you want your ZK VM to be fast. You want your proofs to be generated fast so that you can meet production usage. And on the other hand, like there are so many different use cases in the space, in DeFi, in GameFi, in like consensus even. You want to have that generality that would be able to cater to all kinds of use cases. So for common ZK VMs that you would see in the space, including the core Brevis stack of Pico, the ZK VM layer, they are trying to be both, they are being designed around like generality so that they can meet general use cases. They're general purpose. And on the performance side, there are like many manually built specialized circuits that you can also see in the space, and they're sometimes referred to as coprocessors. So what we're trying to have is we want to have a combination of the best from both worlds for Brevis. That's why the 3-layer tech stack, if you still remember that, like on top of the core layer, the ZK VM, we have the specialized ZK circuits called ZK coprocessors, basically combining performance and generality into one. So this is basically a holistic view of our system. We have on-chain data coprocessor, ZKML coprocessor, and other types of coprocessors that are specialized circuits for acceleration of very specific use cases. We have precompiled functions for crypto primitives. We also are built on top of the RISC-V instruction set. And give you an example of why ZK coprocessors matter to the tech stack. Basically, this is the differentiator of how Brevis performs better compared to other ZK VMs right now is, for example, if we're trying to retrieve data from on-chain and compute over the large amount of data on-chain, the ZK data coprocessor acts differently compared to the ZK VM in that it would be able to prove the existence of any on-chain data. So like the transactions, the trades, any data related to transaction info can be, the existence of those can be validated. And on top of that, the computation process itself is also proved so that you can combine the correctness of the data itself and also the compute on top of it to derive the correctness of the entire result. And there will be a zero-knowledge proof generated in step 1 so that you can take that along with the result to be pushed on-chain to smart contracts in step 2 in a trust-free way. And to offer you some like data insights, without data coprocessors, without these specialized circuits, the vanilla pickle will be able to achieve like 1,200 seconds in proving 96 trades on Uniswap if you are trying to build a VIP loyalty program. But with Pico, with specialized circuits, you'll be able to like shrink that proof time 80 times down. So you can basically prove a user's VIP status within 15 seconds. So that's like the importance and the value of why we are investing so much into app-level coprocessors. And there are different other coprocessors, including for ZKML machine learning. So you can basically prove a 1 billion parameter large language model 100 times faster. And there are light client coprocessors for consensus proving. There are ZK-TLS, which is built to authenticate off-chain data. And these are basically the larger directions the coprocessors are built for. But to be more concrete, there are a lot of different use cases actually running in production already using these coprocessors along with ZK VMs, including intelligent DeFi, including cross-chain interoperability, verifiable AI, real-world assets, etc. And another point I want to highlight is the privacy benefits that come with zero-knowledge proofs, because that's like one of the most talked about points. One use case to give you some I guess ideas if you're a builder trying to look into zero-knowledge VMs and utilize zero-knowledge proofs is you can build very customized dynamic user experience as you are seeing in Web 2. Because in Web 2, we're seeing all kinds of like data-centric user experiences that are that basically evolves based around your in-app footprints. And this is currently missing in DeFi in general, but with zero-knowledge proofs, you can easily retrieve users' footprints from on-chain and aggregate them in a very complex and sophisticated way. So PancakeSwap has integrated with Brevis for their V4 so that they can offer user very tailored trading fees and also discounts. And they have achieved 30 million in liquidity with those pools and 90% LP revenue improvement and 127% liquidity efficiency. You can also build ZK-powered private perp DEX, which is, I think, highly promoted these days in the BNB ecosystem, so that you can hide users' intents for matching, basically batch their order in this matching engine and submit a proving request or a batch of proving requests to the Brevis off-chain ZK compute engine, and the Brevis compute engine will generate a zero-knowledge proof along with the balance state for the order matching results back to the blockchain. And this will achieve, like I mentioned, a very smooth UX. You don't need to wait. It's similar as your experience in centralized exchanges for perp swaps. And it achieves privacy because of zero-knowledge proofs. It is secure because it doesn't introduce any new trust assumptions. It's purely based on Ethereum consensus, and it's censorship resistance. And if you're interested in InfoFi, if you're a Yapper, if you know Kaido, there's also this layer of like privacy-preserving verification that adds value to existing yapping. What that means is that to projects launching leaderboards on these InfoFi protocols like launched Kaido, they would want to definitely reward Yappers who are advocating for their projects. But on top of that, they want their rewards to be a long-term thing. They want to reward maybe DeFi savvy users, DeFi savvy Yappers. They want to reward like diamond hands. And for that to happen, you'll kind of need to find a way to understand the on-chain identities of these Yappers without revealing any private aspects that they don't have consent for you. So how we're doing this is collaboratively with Kaido. We're offering Yapper leaderboards, a way to basically associate Yapper's on-chain identity with their social and identity, so that we can verify like how sophisticated they are on-chain, and we can grant them some extra benefits like a multiplier to their yapping, but without exposing their wallets on-chain or exposing their on-chain activities. And there are also other types of like privacy-related features. Another use case that's probably going to be my last highlight for the use case session for like ideas that you can try out, which is in the real world asset distribution scenario. So like a lot of the projects are trying to like launch their own stable coins or their real world assets. And how do they build growth and adoption immediately after the launch of those assets? It is a really large challenge, because you probably will need to have a lot of liquidity across markets so that users can trade with low fees. You want deep liquidity. You also like want diversity for different DeFi primitives. And how we have been tackling this with DeFi protocols like Usual Protocol, which is a RWA solution, is they have a very sophisticated set of rules for how rewards should be distributed across different markets on different chains. They're working with DEXs like PancakeSwap or Uniswap. They work with lending protocols. They work with Pando-like derivatives protocols, and they are also launched on different chains. So they do have a very well-designed system to make sure the reward distribution logic matches their long-term growth expectation. But to implement that very complex set of logic on-chain directly in smart contracts, it's just simply cost impossible. So that's why they resort to zero-knowledge proof and have Brevis to be the underlying compute layer for all of these reward distribution logic, so that they can maintain all of these benefits of blockchain, because no new trust assumptions are introduced. They can be trustless, they can be secure, they can be fair and transparent, which is like the most important value in this initiative. You want to prove to your community that like every reward distribution calculation is done correctly. And most importantly, you want to maintain that level of sophistication of your reward program to align with your long-term growth goal. So this, like we have phrased this as the Brevis continuous protocol incentivization paradigm that can be applied to not only like stable coin growth, but also it's used in linear ignition, which was like a top buzzword, I guess, on crypto Twitter in the past few weeks or past 2 months. So Linea has distributed 1 billion Linea token across different markets on the Linea chain using the same paradigm, the reward distribution paradigm that I described. And MetaMask Card 2, they're rewarding users based on their like eligibility, whitelist-based eligibility, and using Brevis, they can achieve privacy along with like the sophistication. So my prediction is that, like you can see, there is this scaling primitive or scaling benefit that's associated with zero-knowledge proofs. There's also privacy associated with zero-knowledge proofs, which are both needed in blockchain for both consensus and also DApp logic. It is like a great primitive for scaling if you want to build like Web2-like user experiences. It also preserves preserves privacy, not like what we're seeing as a trouble in Web 2. So my prediction is in 10 years, 99% of the computation for blockchain applications and also in consensus is going to happen off-chain, verified by zero-notch proofs without introducing any new trust assumptions. So last, I want to also share that we are launching our prover net, which, if you remember still, is the bottom layer of our 3-layer design that functions as the matching engine for compute resources and compute needs. It's built for heterogeneous workloads because we see there are like workloads for consensus, there are workloads for real-time application needs. There are workloads for like last real time and more security focused needs. So these different workloads definitely would need different hardware resources. So that's basically the context for such a proven net initiative. And we have released a white paper for the design of it, and we're like foreseeing the launch of the proven net in mainnet very soon. And what's unique about our proven net, the matching engine, is its truthful online double auction system. So this is a like new, totally new concept innovated by our team, and it basically ensures that the buyers and the sellers can always bid for their true value, which has already been a common thing in like game theory or auction systems. But what's unique or what's being innovated in our system is that it also allows like free exit and free entries into the system. So you don't necessarily need to wait for a long period of time for the matching to happen for true values. And lastly, like there is also the Brev token associated with the proven net that has utilities including for payment and for staking as a gas token and for governance. So there's a lot to explore with Brevis, whether you're a researcher, you're a learner for ZK, you're a builder that tries to build data-driven logic, or you want to explore consensus using ZK, Brevis probably is something that you can look into. And you can feel free to follow us on Twitter at Brevis_ZK. And if you have any questions, feel free to reach out to us on Twitter, and we'll be happy to answer any questions. Thank you.
All right, next we have Lucas, who is the head of smart contracts at Phoenix Labs. He will be giving us a deep dive into version 2 of Spark Savings. Spark is the first star in the Sky ecosystem, manages over 3 billion in assets on chain, and generates institutional grade yield. Please welcome Lucas.
Okay. So the purpose of my talk today is going to be to talk about Spark Savings V2, but I think it'll be a really good thing for us to do like an overview of how we got here and just like add a lot more context. So what I'm going to do to start is to give you like a bit of history. So Sky, formerly MakerDAO, started by issuing DAI debt against over-collateralized positions. So who is familiar with the original MakerDAO system? You guys? All right, awesome. So you basically put up Ethereum as collateral or ETH as collateral or any other crypto asset, and then you can generate debt against it. So you can mint new DAI, and then you owe interest against that position. So this system worked very well. It scaled well. But then in DeFi summer in 2020, there became a massive influx of demand because all of these new primitives were being built, all of these farms. I don't know if any of you guys were around for that time, but it was really fun. But DAI became a bit of a victim of its own success, where the demand for the token actually outpaced the amount that people were minting it against their crypto collateral. And so Maker tried pulling a bunch of different levers. One of the levers was like reducing the interest rate to 0%, and even that didn't work. So some back and forth was had. It was kind of a controversial decision at the time, but I think it was the right decision, which was to onboard a new module, which was the peg stability module, or the PSM. So the PSM essentially allows one-to-one swapping between DAI and USDC. And the idea behind this was any excess demand would flow into the PSM, so people could get their DAI by just giving USDC into the system. And why this was controversial was there became a pretty large, I can actually show you here, pretty large amount of the backing of DAI, which used to be purely crypto collateral assets, became stablecoins. So that was a bit of a controversial thing, but it allowed DAI to scale to be much bigger than it was before. So what happened was, the maker system got a lot of USDC on the balance sheet, and then on the order of billions of dollars. And what happened pretty quickly, what became pretty clear, was that this was actually a massive opportunity cost for the system, just to have idle US dollar stablecoins sitting on the balance sheet. So the next sort of phase of work was, how do we earn a yield on this, right? So shortly after, it was a couple of different approaches were taken to this, but ultimately we were able to start getting the treasury bill rate on these stable coins through a deal with Coinbase. We also had some different like RWA setups for that. But after that, especially in bull market conditions, the opportunity cost was still too high, right? Because there's really great yield opportunities, and it was determined pretty quickly that Maker's like extremely robust, super, decentralized, large, single-threaded governance system is very well suited to, economic policy of a decentralized stablecoin, but it turns out it's not very good at making quick, snappy, like well-aligned decisions for asset management. It was a difficult time for actually like determining how to earn the best yield, the best risk-adjusted return on these stablecoins. So what happened was Sky, during this time, by the way, like the rebrand went from Maker to Sky. So for the rest of the presentation, I'm gonna say Sky and USDS, which was previously MakerDAO and DAI. DAI still exists, but I'm just gonna, for simplicity's sake, I'm gonna just continue by using USDS. So after that period of time, Sky released or launched the first star. So Spark, where we're working on, is the first star in the Sky ecosystem. The previous term for this was a sub-DAO, which is more descriptive, which is basically, it's a DAO that gives a large portion of its token equity to Sky in exchange for the ability to borrow at a wholesale interest rate from the Sky system. So Spark has the great privilege of being able to borrow from this large amount of stablecoins on the balance sheet at a relatively low interest rate, and is able to allocate into different opportunities based on that. So you'll see here, this is what we've been working on for the last while. So the Spark liquidity layer is, here we go. The Spark liquidity layer is an automated asset allocation system that will borrow from Sky at the base rate of 4.8%, currently borrowing just over $3 billion worth of value, and generating 5.2% APY, earning a 0.4% spread. And this APY, it's currently decently bearish conditions, but this APY can be quite larger in bullish conditions. But the idea is, everyone benefits, right? Sky will earn a higher base rate because of more effective deployment of capital, and Spark is rewarded for doing the work to achieve like a really good risk-adjusted return. So you can see here we're currently deployed into Sparkland, Maple, Morpho, Superstate. And then we have Position and Curve, but like also Aave and Athena have been onboarded as well. Merlin from Morpho will be talking later today. We have a really very interesting integration with them on Base that I can go into later on if I have time. But essentially, Spark is a stablecoin asset manager, pretty much. And with that, we have also launched Sparkland, which is a a fork of Aave v3, but with a more concentrated collateral profile that's extremely conservative. And we are the largest LP by far for the stablecoins. So essentially, it's somewhat analogous to the original core vault system where it's over collateralized crypto lending. But instead of it being through the core MakerDAO vault system where people are minting against their positions through Maker, we've just launched a money market and we're adding liquidity to it, and then people can borrow against it. So yeah, that's the Spark liquidity layer. That's the brief history of DAI, how we got here. But it's all sort of important information because I have a mental model for these different tokens and how they work. And I think it's important to have this sort of broader context before going into that. So my sort of idea behind this, right, is like USDC. I'll stick with USDC alone for this presentation, but essentially it's a centralized stablecoin where you have an issuer. Actually, I might start whiteboarding at this point. If I can erase this. One sec. Okay, so you have your US dollars in the real world, right? They get deposited into Circle, and then they will issue USDC on Ethereum. Let's say, let's say Ethereum just for this presentation, to keep it simple. And then so USDC in this like mental model that I have, I consider it to be like cash. So like if you have, US dollars in your wallet and you come to Sky, you can deposit this USDC and then receive USDS. Oh, sorry. So USDS. USDS can be used in DeFi. It has benefits, but the real main use case of the biggest driver of demand lately for USDS has been SUSDS. But basically, what's happening in reality is this USDC is going into the PSM, and then USDS is getting minted to the user. This is the equivalent of a checking account at a bank. Essentially, is my mental model of it. You're giving cash to the bank. It's not a bank, but it's a smart contract. And then we're minting a deposit token equivalent. So it's basically like a balance in a checking account. And now the USDC is sitting over here, USDC. Sky can be deploying that in different ways to earn a yield. So in order to drive more deposits, increase demand, all this kind of stuff for the stablecoin, we've launched SUSDS. SUSDS users can put USDS into, and then all of the yields that gets generated, some of it will flow back to the user. So this is the equivalent of a savings account. So the whole sort of process is a user will deposit in the PSM, receive USDS, and then take that USDS and put it into SUSDS, then they'll earn the savings rate. To a first-time viewer, this is a pretty non-trivial, somewhat complicated process, right? Like they just want to earn a yield on USDC. Like they don't want to understand what a PSM is, what the liquidity implications are. All of this information is somewhat difficult to understand for a first-time institutional, non-DeFi familiar user, right? So this, go back over here for a second. So SUSDS alone and SDAI, both were very successful within DeFi. Like SUSDS has 2 billion in deposits because enough people, enough capital knew how to do this and wanted to deposit. What the Spark team did for the first version of the Spark Savings product is we launched something called SUSDC. So sorry, I should rewind. Before that even, we launched just a front end for SUSDS that made it very simple, easy to understand. I can actually even like show you briefly. Spark.fi savings. If you go in here, like this is just like a very nice interface to use to deposit funds. That was the first step that we had. Was like, okay, let's get more users into SUSDS, because as I was talking about before, if you guys remember, the more USDC that goes into the PSM, the more capital Spark has access to deploy and earn a spread on. Because you can basically think about it like Spark is down here. We can mint USDS, swap it in the PSM, and take out USDC. So we're on the other side of this, right? So yeah, Spark can basically mint their USDS, put it in the PSM, take out USDC, and then deploy it into DeFi, pay an interest rate to Sky, and then earn the spread on that through the yield. I'll stop there for a second. Does anyone have any questions about that? Because I know it's like, yeah.
When you generate USDS, and can it be redeemed or can be used for some other purpose?
When you redeem USDS?
No, when you generate USDS.
Yeah.
So when I put my USDC into PSM wallet, and then you give me a token, which is like USDS.
Yeah.
So if I use somewhere USDS, I believe USDC will also get burned.
Well, if I'm understanding correctly, you're adding USDS to the PSM.
No, I'm not adding. I'm just getting a representative token as a USDS, right?
Yeah, you're effectively doing a swap. Is basically what it is. That's the way to think about it. Yeah.
And so that USDS can be used for any other purpose?
Yeah, it's a stablecoin. It can be used in DeFi. It can be used for payments. It can be used for anything. USDS is in many ways exactly equivalent to USDC.
So the owner so the wallet, if I transfer USD to somebody else, and they are now the beneficiary for the yield, whatever.
Yeah, great question. Great question. So USDC is a stablecoin, centralized stablecoin issuer. USDS is also a stablecoin with a decentralized issuer with a large backing of collateral, over collateralized. SUSDS is a yield-bearing stablecoin. So this is an ERC20 token. And this is one of the narratives that we're trying to push that's very interesting, is it's basically like a hedge on inflation. Like if you treat this as a currency, like you can just transfer this around and it's just a naturally appreciating asset. This effectively functions the same way as a stablecoin with a yield baked in. But it's, people aren't using it for that use case yet. It's more just parking it and earning a yield.
So what is the difference between USDS and SUSDS?
USDS has no yields and SUSDS earns a yield. Yeah.
And say for an example, I generated a USDS and I didn't transfer it into SUSDS, but I given to somebody else for the payment. And that beneficiary then transfer to SUSDS, then that wallet is eligible for the yield. I'm not the one who is.
Yeah, these are all fungible ERC20 tokens.
Okay.
So yeah, they can be transferred around and exactly. Yep.
Thank you.
Good question. Similar, not the same, but very similar. You can think of it in the same way. The difference, and I can actually get into this more now. I'll get into this more. I'm going to finish this thought, and then we'll continue to move on. So the idea, the main idea here, right, is that Spark's balance sheet of tokens is, this all came from Sky, and we minted this, and we're we're paying an interest rate on it. But the ability to do this comes from there being a balance of stablecoins in the PSM. Without that, we're not able to perform this kind of operation because we're effectively borrowing USDC from Sky. That's like the very big simplification of this. So in Aave, users are adding USDC into an Aave market, and then there's a borrower on the other side of that, and they're paying interest, right? In Sky, it's a little more convoluted in the back end, but it's a lot more robust, and it's actually a lot better. The user will deposit into the Sky system. They'll earn this savings rate, and the yield over here is getting generated by multiple stars, one of which is Spark. And Spark is generating that yield from allocating into many different protocols on different chains. So that yield is much more diversified, much more robust, much better suited to take advantage of market conditions. Like, for example, in a bull market, we can add funds to Athena and capture like really high yields. But in a bear market, we can also put it into BUIDL and earn just the straight up treasury bill rate. So the yield on SUSDS is, the max between the TradFi T-bill rate in a bear market or the like going DeFi rate in a bull market. So yeah, I will continue here. So back to my point, my original point, right? I'll make it a simpler diagram again. So you have, USDC, you put it into the PSM. This will give you USDS. Then you put that into SUSDS. This is the full user flow to get from USDC to SUSDS, earning a yield, right? So this was not super straightforward to first-time viewers. Like, they didn't know what a PSM was. They didn't know how liquidity was managed. They didn't realize that there's $3 billion of active liquidity. Whenever we're talking about yield-bearing vaults, one of the biggest concerns that institutions have, which is very legitimate, is how much liquidity is there? Like, can I enter and exit with size immediately? And no one even comes close to, the vault liquidity that Sky has. So people can enter and exit into USDC very easily through the PSM because this has $3 billion of liquidity. So the first version of what we built was something called SUSDC. So what would happen, I kind of drew this a little too close, but a user would add USDC into SUSDC, and they would receive SUSDC tokens, and that's all they see. They just put in their USDC, they earn a yield. What's happening in the background is we're taking that USDC, putting in the PSM, getting USDS, putting in the SUSDS, and then making this the underlying token for SUSDC. And then if they want to withdraw, it's the opposite. We take their SUSDS, convert it into USDS, take that in the PSM, put it onto USDC, and they receive this USDC. So from the user's perspective, they're just depositing, withdrawing from a vault, but in the back end, we're doing these operations for them. That was the first version of Spark Savings, and it was, it was quite successful. We got to, 1.3 billion in assets. Yeah, 1.3 billion of USDC holders that wanted to earn a yield and deposited through this mechanism. And then after this has grown, we've been thinking about this further, and we have created our second version of the vault, which is the purpose of this presentation. You now know why I couldn't just jump into explaining this. I had to give all the context. So SUSDC v2, which we're calling SPUSDC for Spark, is the user will take USDC, and that will go into a simple SPUSDC ERC4626 contract, and it will just sit there. it'll just sit there idle until the Spark liquidity layer sees that this deposit was made, and the Spark liquidity layer will pull the USDC out and then allocate it into all the different strategies that I was showing above. So you'll notice in this flow that Sky is not actually a part of it. We're not using the PSM. We're not using any of these tokens. We're just using USDC, 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 all the way down. And what is a valid, actually, sorry, one second. We have USDC, SPUSDC, Spark liquidity layer. This deposits into a bunch of different strategies. We also have launched SPUSDT, so our Tether vault. And this is also run in the same way. We're just dealing with the native asset, taking it into the Spark liquidity layer and deploying it. And the key thing here now to know is that Spark is now in charge of managing liquidity for these vaults, because we're no longer directly tied into this PSM mechanism. There needs to be actively managed liquidity within each of these vaults to allow for people to withdraw. So it's much more akin to a traditional vault, except the key advantage is that Sky is already managing a $3 billion balance sheet of stablecoins. So there will be no issues meeting the demand of liquidity for this, because we can always swap between these tokens. We can use the PSM if we need to, but we're already holding a large inventory of different stablecoins. I can show you over here maybe. USDC is 1.2 billion. USDT, we have 550 million. PyUSD, 500 million. We have different, and USDS over here, 398 million. These are the stablecoins that we can use to facilitate exits from these vaults. And we can also swap between them pretty easily as well. So we're in a very unique position to provide, an extremely competitive risk-adjusted yield product. This is important to note. Like, we're never going to outcompete the most degen DeFi vaults. Like, that's not why we're here. Like, that's not what we're doing. We're looking to talk to institutions. We're looking to get institutional grade capital, people to put their life savings into this vault, because there is, very high degrees of protection, very sophisticated risk management model, and very deep liquidity. So yeah, I will stop there for any more questions. Yeah.
How decentralized is the SLL?
The Spark liquidity layer? Yeah, that's a great question. So this is what I've been working on for the past year and a half, I think, and it's been very fun, fun to design. So the on-chain, the smart contracts essentially are very restricted in terms of what can be done. So all of these protocols that you see here, all of these were onboarded through Sky's governance process, which is a very methodical, slow-moving, decentralized, robust governance system. It's basically impossible to subvert this. So these are onboarded, and they're onboarded with rate limits. So you can deploy $1 million per day into Maple, for example, or whatever it is. And there is a off-chain system that is run by a hot wallet, and it is, it's controlled by an entity, and it's running, and it's making the decisions to move between different markets depending on different market conditions. This has actually been something that's been really cool to see. It's actually helped the DeFi markets become more efficient and mature. Utilization rate-based markets like Aave and Morpho, typically in the past, when there was spikes in demand, there would be a spike in a borrow rate, right? And that would be a very bad user experience for someone using DeFi for the first time. They're like, why did my borrow rate just go up by 5% in half an hour? This is not sustainable. I don't want to use this product anymore. Spark liquidity layer is on the other side of that and says, hey, we have this $3 billion balance sheet. We will happily reallocate between all of these different markets to compress the rates, keep them within a certain range. So we'll just move around basically to keep all these rates in a very stable spot. And so to answer your question, when we were developing this system, we intended for it to be able to be entirely compromised by a malicious actor. We've designed it off-chain to be extremely robust and very safe, but we can't put the fate in the system on some off-chain system. So we designed the actual on-chain system to be able to be compromised entirely by a malicious actor and for them not to actually perform any malicious actions. They would be able to move funds between different DeFi protocols for a period of time. The alarm bells would go off and we would remove them from the system, but no actual value would be able to be extracted. Yeah. And also another thing that's important is the decision-making behind the rules-based allocation system is posted on governance forums and voted on. So it's not like someone's just like making a decision. Like it's gone through governance. Yeah. Anyone else? Good question. Yeah, I mean, the first step is to get institutions on chain at all. I think we're actually gunning more towards institutions that have idle USDC. Ideally, all of the USDC would just be gobbled up by Sky and held as stablecoins, and then it would be allocated properly within DeFi to earn their best risk-adjusted return, and then everyone would be earning the Sky savings rate. That would be like the ideal outcome, but there is a ton of opportunity cost where institutions are just DeFi institutions are holding USDC instead of earning a yield on it. There's two sides to this. Like there's borrowers that want better borrow rates, better market borrow rates, and there's lenders or people that are holding capital that could be earning a better return on it. And so Spark is facilitating that, the connection of that capital on both sides. Yeah, we talked about this for a long time actually, because it's not ideal that Sky starts with an S, Spark starts with an S. So SUSDS is a Sky product. Sky made this, and it's owned by them. SUSDC was the first version of the savings product that Spark made, but for the exact reason that you just mentioned, people just immediately associate it with Sky, which is fair. It's literally just putting it into Sky anyways, so it's not that bad. But to kind of own the brand a little more and own the token, we changed the prefix to SP, SPUSDC. Yeah, I mean, we're always staying up to date on the latest developments in the sort of legal landscape. My hope is that there's just going to be sort of two classes of stablecoins that emerge. The highly centralized, custodial, compliant, US-based Genius Act compliant stablecoins like USDC, and like Pi USD, for example, also right here, PayPal's stablecoin. And then there will be decentralized stablecoins, which are effectively they're stablecoins. They can be used as stablecoins, but they're a different product almost, because they're a representation of a US dollar through different mechanisms, market forces, all this kind of stuff, over collateralization. But there's no actual custodian of the backing assets, right? It's backed through DeFi, through crypto collateral, all these different things. So my hope is that this will benefit both sides. So we were talking about in the last presentation launching a stablecoin and how difficult that is, and it is very difficult because there's network effects involved in deploying a stablecoin. So PayPal approached Spark, and we made a deal to launch PayPal USD with liquidity in Sparkland. And we figured out a business arrangement to basically become like a stablecoin launchpad for them. And so we swapped a bunch of our USDC into Pi USD, and then we lent that into Sparkland. Pi USD had a lower rate than USDC in that market, so people are incentivized to use it for their operations. And then all of a sudden, you have a much larger supply of circulating stablecoins in the market, which benefits everyone. It benefits PayPal, benefits us, benefits the user. Everyone wins. So what we're hoping is through the Genius Act, more and more institutions, like issuers, will want to launch stablecoins and put them on chain and hopefully partner with Spark or other stars to launch them. And then we just get again, like everyone wins. Like it's the Genius Act stablecoins get deployed, but they get deployed in a way that they actually get utilized in DeFi by the right people. So they get put in contact with the right people immediately, because you can't just mint a billion stablecoins and just kind of like expect them to get used. Like they need to be leveraged in the right way by the right actors. So yeah, that's my hope, is that everything will grow because of that. So if I understand your question correctly, you're saying how will it impact the industry as a whole and Spark, as there's like JP Morgan coin or like all these different, stable coins that get issued? Yeah, it's a good question. I think we will live through a time where there's going to be a lot of stable coins for a while, and I don't think that's a bad thing. I think through mechanisms like the Spark liquidity layer, through mechanisms like really solid AMM liquidity and all this kind of stuff, like we're going to be able to abstract away a lot of the different stablecoins away from the user, from the end user. And this is really, again, it comes back to the Spark savings product. Like Spark savings, you can deposit you can deposit USDC, you can deposit USDT, you can deposit Pi USD in the future, whatever it is, JP Morgan coin in the future. We're going to create a savings vault for all of these stable coins. We're going to consume all of them. We're going to add them into the Spark balance sheet. We're going to deploy them into DeFi. We're going to aggregate all the yield that's generated by those stable coins, and we're going to redistribute all of that yield to all of the corresponding vaults. We're going to represent that value accrual, and then when people want to exit their positions, we will facilitate that exit by like moving funds between these different stablecoins to allow them to exit. So it's this like mass stablecoin yield aggregation that's going to really simplify how things are done for the end user. It's a big benefit. Anyone else? Yeah. There's definitely smart contracts for sure, but they're very simple for the user to interact with. And then there are more smart contracts in the back end that the Spark liquidity layer interfaces with. Those are more sophisticated. They're more, robust and complex, I guess you could say. But for the user, it's dead simple. They deposit into a 4626 vault that has a function for the Spark liquidity layer to pull liquidity from it and allocate yield. There's also another function in here for Spark governance to set the rate of accrual. So it will be continuously compounding in these vaults. It's not dynamically derived, it's set. And so, yeah, the governance team can basically determine the rate at which the value accrues. They're not deprecated, they're still around. I used to work on them. Right here, you can see this little guy right here, which is 500 million. Like, that's not small, that's big. That was like, the main source of liquidity, but you can see now, right? Like Sky has, scaled. We're almost at 10 billion in stablecoins outstanding. And the way to do that was to incorporate all of this like stablecoin related asset balance sheet management. Yeah. All right. Thanks, guys.
Right. Next, we have Inco. This is going to be Furkan. He is a researcher at Inco. Inco is the missing layer of blockchain stack, empowering smart contracts with confidentiality to unlock use cases, enable widespread Web3 adoption. And Furkan is going to give us a deep dive into privacy-enhancing technologies and how Inco enables private compute. Please welcome Furkan.
Hello, thanks for the intro. It's Furkan, and I'm working at Inco as a researcher. And today I'm going to try to give a sort of overview in privacy-enhancing technologies, and starting with why we need privacy, and then how we can enable privacy, and comparing different privacy technologies in blockchain sense. So first, the problem statement, right? The problem statement is, today, all the on-chain data are public. And this is one of the biggest bottlenecks towards mass adoption, in my opinion, because no one wants to reveal their salaries or their investments in DeFi or their votes to in government votings or in company votings, anything. So we need at least optional privacy, regardless of it is going to be used or not. And according to a study, lack of privacy is one of the top 3 reasons why we're still having some trouble having the biggest institutions in crypto. And this is a dilemma, right? Transparency and privacy, it is both needed, because we also need some sort of transparency to make things traceable, also to make things verifiable, but we also need privacy because of the reasons I've just mentioned. But privacy is a spectrum, and I find this table quite important because most people are confused about these different notions, right? We have the default privacy as we have in the current on-chain system, where, okay, we have some addresses, and we don't have to put our ENSs on our Twitter accounts, which most people still do. We call it pseudonymity. But it's not quite private, because if someone can find a link between your identity and your on-chain address, then all the on-chain activity would be revealed. There is confidentiality also. Let me show it here. Okay, in confidentiality, let's take a transfer. Sender and recipient are public, but the amount is private. So the biggest probable example here is like payrolls or supply chains, where sender and recipient can be public. For instance, you're working at a company and everyone knows that you're working at that company, but you would never reveal your salary, and you can use a confidential system here. And some examples are Solana's confidential token extension, Avakla's ERC, and our confidential tokens, which I will give more details in a second. The other type is anonymity, where the amount and the asset type are public, but sender and recipient are private. And the here example use case would be a medical visit or a political donation. You can reveal your, if the amount is fixed in a political donation system, it's not important if it's public or private because it's already fixed, but you wouldn't want to reveal that you're actually donating to a political institution and which political institution you're donating to. And an example here would be a railgun system. In railgun private system, addresses are not public, but the amounts are visible on chain. So finally, this is thing we call total privacy, where everything is private, right? The sender, recipient, the amount, and the asset type. And example use case would be transfer of very, very sensitive assets. This is the version where you can see it as a spectrum from pseudonymity to full privacy. But obviously, when you go to right within the spectrum, the compliance risk significantly increases with the degree of privacy. As everything is hidden in a fully private system, it's not that easy to put a compliance mechanism on top so that the privacy protocol wouldn't be used for money laundering or any other malicious activity. Okay, I think it's quite clear that we need privacy, but how are we going to enable it, right? These are different possible solutions towards that. And let's start with fully homomorphic encryption. Fully homomorphic encryption is a cryptographic primitive where it simply enables computations and operations on top of encrypted data. So obviously, one example would be a simple mathematical addition or multiplication, no matter what that is, or the other would be a comparison, right? You can compare two encrypted data. For instance, if you're gonna build a confidential DeFi application using fully homomorphic encryption, you will need these comparisons while you wanna do a transfer, because the transfer amount should be less than or equal to the sender's balance, and if everything is encrypted, you need an encrypted operation or homomorphic operation to do so. And FHE allows that. FHE actually was only a hypothetical idea till 2009, where Craig Gentry comes up with the idea of bootstrapping to reduce what we call noise within ciphertext. And a lot of different FHE schemes occurred since 2009 till today, and the benchmarks also very improved. However, it's not super efficient right now for daily use, especially when the data size is big, the operations are costly. But on the blockchain setting, there are several projects doing FHE thing very good, but it's still on research. The second is the trusted execution environments, which you also probably are familiar with. It simply separates the hardware, a untrusted area and trusted area, and you run your key storage or encryption decryption procedures within the trusted area, or what we call secure enclave, and that allows you to perform encrypted compute on top of these DEs. So this is one of the case studies we have within the slides. I'm not sure how many of you had seen before. This was our research with Circle Research last year on a confidential ERC20 framework. So in a usual ERC20, there are some fundamental functions, right? There is mint, there is burn, there is transfer, also approval, transfer from, and stuff. So, and we've been thinking how we can make this confidential. So senders and recipients are going to be public, but the amount is going to be private. And in this setting, we used FHE last year, and we simply built a new smart contract library where we have some encrypted types. Okay, let me clarify here. So we have some encrypted types, like for instance, in Solidity, we already have some integer types, addresses, booleans. And in the new library, we have encrypted integer, encrypted boolean, encrypted address, and some methods to convert a plain text to a ciphertext, to an encrypted version. And for instance, by modifying the balances mapping from address to an encrypted integer, also we modified the, let's say, transfer function. The comparison is done in an encrypted manner. The transfer is done in an encrypted manner. You simply subtract the amount from sender's balance homomorphically. Also, you homomorphically compare the balance and amount. So that's both a paper and the implementation is available on this link. Also, another thing is this approach difference, right? So especially privacy, as privacy is quite on hype these days because of several reasons. People are discussing if ZK is the best solution, or TEs, or FHE, or MPC. But I actually personally prefer splitting this discussion into two: commitment-based approaches and encryption-based approaches. Commitment-based approach, decryption rules are rigid, decryption key is individual, and mostly there is no private state composability, where in encryption-based approach, decryption rules are flexible, decryption key is shared mostly, and private state composability exists. So in a commitment-based scheme, mostly ZK-based schemes, decryption rules are quite rigid, right? There is a viewing key set up. You can share your viewing key to someone else to see the underlying plain text, but you cannot make it flexible to, let's say, an access control list, or you cannot use any, let's say, commitment-based privacy token in a DeFi. That's the main thing we mentioned about lack of composability. On the most encryption-based approaches, which we also use, there is secure and flexible on-chain access control. For instance, there are users and delegators, auditors, and government, let's say, and you can define some on-chain decryption rules to make it compliant. And either it is an MPC or TEE, without needing any new wallet, you simply make it accessible to, like flexibly accessible to any third party, or maybe you cannot, you also are able to make it no flexible to any third party and no compliant to anyone, but that would be your responsibility, obviously. Yeah, as I said, flexible decryption is quite important to manage compliance and risk. We all know what happened in the Tornado Cash case, and as the folks within the private space, the compliance is quite an important thing to consider without making our projects and putting them on production level. And if you have flexible decryption rules, you can make it more compliant to third party and some very well known principles. So yeah, in most commitment-based approaches, there is no composability, right? And when you have a confidential token, for instance, based on this commitment-based approach, you cannot use it within DeFi, within voting systems, and the other probable use cases. And that's why ZK-based privacy protocols are mostly accomplishing composability in a very, very different way. They're not, for instance, like in Railgun, they're doing it within their privacy system, where you need to install a new wallet, and that's not super composable with both different apps and also the existing wallet that you probably are using. And this is what we essentially mean by lack of composability. And in our case, the confidential ERC20, either it is FHE based or TE based or MPC based, you can use it in a similarly built voting protocol, payment protocol, or lending protocol in DeFi. But obviously, it will require a new setup. If you're not going to use any proxy account setup or something like that, you will need to build a, let's say, confidential lending protocol using the same smart contract library. And if you do so, you can easily import your existing confidential tokens into new protocol, as they will both be composable with each other. So yeah. And we call this thing encrypted garden, with confidentiality in gaming, custodian, card payments, trading, governance, lending, blind auction, and everything. So this is what we want to actually achieve by making everything confidential. So this is another thing, programmable transfer rules, right? So you can enforce some rules over plain text and encrypted information directly within smart contracts. That would that is a transfer limit or an age limit. You can define it within the smart contract by using our smart contract library, and that would reveal nothing. You simply compare a encrypted age, for instance, age value, to a either encrypted or non-encrypted age limit, and the smart contract in the behind the scenes will do this comparison on encrypted manner. So in this case, age is not going to be revealed. In another case, let's say the transfer limit case, the amount you want to transfer will not going to be revealed to anyone. So if it is FHE, it will be done homomorphically. If it is TE, it will be done within the secure enclave simply. And this is the confidential token association that we founded with Zama and OpenZeppelin at the first place to drive the development of on-chain confidentiality and via bringing a confidential token standard to make new confidential applications available and also composable with each other. And Inco enables private compute on existing blockchains using an encryption-based approach. The first part is very important, in my opinion, on existing blockchains part, because we're not building a new L1 or a new L2, which I think is great because users are not gonna need to set up a new wallet or bridge some funds to a new chain. They will simply use Inco on top of their favorite L1 or L2. This is our analysis to why existing solutions fall short. So first, the cold start problem, right? Users need to migrate to a new L1 or L2 privacy chain. They need to bootstrap a new liquidity, ecosystem, and user base, which is, I think, really hard. The other thing is user and developer experience. It's mostly limited programmability, composability, and challenging developer experience by like new programming languages, new tools, and etc. Also, the final thing is compliance. As you already seen, the unfortunate Tornado Cash case. And that's why we think compliance is a very important thing within the private space. And I think there is no problem with, I say this here. We've been working on a research with predicates on privacy and compliance within the on-chain space, and the report is gonna be released at the end of November. But I'm super open to discuss some insights afterwards after this call. So I also want to give some intuitive explanation to our smart contract library. I already mentioned that we have encrypted types and methods, but they look essentially like this. So you simply put E in front of the variables and also the methods. You simply call the addition function, subtraction, multiplication, or equality conditional from the library, and this is going to take place within your usual smart contract. So at the end, you will leverage you will use the existing user base, and you will have the joy of simplicity of writing code, and you will build on top of existing TVL. Yeah, creating or modifying an application in Solidity takes only 20 minutes, which I think is pretty fast. And you're not gonna need to learn a new programming language or a new tool to build a privacy-preserving application. Yeah, this is another case study, wrapped ERC20 compliant confidentiality. So that's actually a very good exercise for everyone to build a compliant private wrapped ERC20. We already built it. You can check out our Comfy product, where you simply bring your existing tokens, the ERC20 tokens, obviously, and the protocol converts them into a wrapped encrypted versions. And as you see right here, I hope it's quite visible. It simply does exactly the same thing as the regular ERC20, right? It simply checks if the sender's balance is greater than or equal to the value of transfer, and then convert it to an encrypted version. And this simply updates senders and receivers' balance on encrypted manner by calling the addition and subtraction methods. All right. Yeah, another case study would be confidential governance, because you can build anything using the smart contract library, and governance is another use case. You can hide the voting choice, you can hide the voting power, and obviously it's gonna be fully on chain and permissionless. So in this example, obviously the votes are encrypted. The voting construct, the tally is encrypted, but you can change it, right? You don't have to make everything private. You can also make some parameters public, like the voters itself, or some votes maybe, or maybe like the tally process could be public. So it's up to the design choice. So gaming is another use case. For instance, here, on-chain poker is one of the use case. So that's actually the main trouble to build a poker game on blockchains, right? Because you need to hide something, some cards, and it's not quite possible without any privacy layer. And Inco is one of the ways to make it possible. Another thing which I want to mention is hidden randomness is another use case. You can like sample some random variables in an encrypted manner by calling the rand method, which is pretty useful in most game setups, which is, I think, pretty cool. Yeah, the current focus in the private space right now is mostly on payments, but we do think it's more than payment. In DeFi, there are several things like trading, lending, or like pool stuff, vaults, and everything. There are some extra toolings like voting, private marketplaces, private identity, which is another very, very important topic, and obviously gaming. You can try this today. Our testnet is live on base Sepolia. If you visit our docs, you will see a really, really fast introduction tutorial to start building on top of Inco. And I want to thank you to be here, listen to me, and I hope it was instructive. If you have any question, I would love to answer right now. Thank you.
Hi, everyone. All right, I just click. Okay, that works. Let's go. Oh, okay, maybe for the questions. Let's go. Cool. So today we're going to see how Morpho is architectured. So first, a few words on Morpho. So we're building the universal lending network. So basically a liquidity network on top of which anyone can build, earn, borrow, creation products. So there's over 12 billion in assets, depend also on market price, of course. So today might be 10 or something like that. We've raised like 70 million in total with a 16Z rebate capital. And we have multiple partners in the space, like crypto.com, Gemini, Coinbase, Binance, Ledger, etc., that are using Morpho and leveraging like Morpho as on-chain infrastructure. Our thesis is, if you check banks, how it's built today, it's every bank is kind of like repeating the same pattern. They have their own teams, their own servers, their own backend, their own COBOL infrastructure that are repeating the same thing. And there's 50K, about 50K of those financial institutions in the space. All of those are kind of siloed, which is a huge issue in terms of inefficiency and other stuff. That DeFi is kind of solving. And this is our DeFi thesis, is that the whole financial system is going to use DeFi infrastructure, DeFi protocols to power their backend, and they will focus on their front end on providing the best product for their users. For instance, Morpho is going to be the DeFi infrastructure for crypto.com, Coinbase, Societe Generale. All of those will use Morpho as backend. So, for instance, Coinbase users will deposit USDC on one side to earn yield, and on the other side, crypto.com users will deposit Bitcoin as collateral and borrow USDC. The whole things creates a nice flywheel, deep liquidity, and better rates than you can get through financial systems. So that's that's Morpho in a nutshell. Here's the architecture. So Morpho is, you can see there's the market level and what we call the vault level. So at the market level, you'll have users that comes in, deposit collateral assets. So it can be wrapped active, Bitcoin, wrap if, whatever, and they will deposit, usually stable coins. They will borrow that, they will pay interest that will go to lenders. Usually lenders will go through another set of smart contracts, which are called Morpho vaults. So for those that are quite technical, it's ERC-4626 vaults, which is the common standard for vaults. And lenders or distributors, when it comes to centralized exchange, fintechs will deposit into that vault. That in turn will allocate those stablecoins to the different markets. And a curator will be there to do the risk curation, risk management. So I'm going to go. I'm going to dive into all those smart contracts. So first, at the market level, a Morpho market is isolated from other markets. So if, for instance, shit happens on wrap if USDC because for whatever reason wrap if asset is hacked or there's depeg or whatever, if it affects this market, it won't affect the others. So there's true isolation of risk. So I'm a borrower. If I borrow on that market, I don't fear to be affected by other markets if there's a market crash, which is quite different from other lending pools where usually you deposit your asset and you're exposed to all assets that are listed in the pool. So I don't know, for other lending protocols, if you're a pure USDC lender, you might also be exposed to X Sushi or Ifina PT tokens that could be listed in that pool as well, which is not the case in Morpho. So you have those markets. A market is defined by a collateral asset, which is an ERC20 token, a loan asset, an interest rate model that is doing the accounting of how much borrowers needs to pay to lenders, LLTV, which in other protocol you can it's called collateral factor, sorry, and an oracle, which is pricing the collateral asset in terms of the loan asset. As I said, it's risk isolated. A market is immutable. So there's like the DAO, the Morpho DAO cannot update and change the parameters of one market. And one advantage of this is if you build a product on top of Morpho, it stays as it is. There's no entity that can change and break the product that you've built. It's immutable. It's trustless by default. And liquidation happens at the market level as well if the position is underwater. I'll go into the details. So first, about the interest rate model that is being used in the market. So there's two components. There's the curve mechanism, which is a classic mechanism that you have in lending protocols, and an adaptive one that takes into account the market conditions. So the first thing is the curve mechanism. So for instance, the utilization that is targeted at the market level is 90%. What that means is, let's say there's $100 of deposits. The market will try to converge to $90 of a borrow. So if we see here at 90%, so which is the utilization target, the curve mechanism makes the rate to spike whenever the utilization is above 90%. Why does it spike? It's because if there's high utilization of the pool, that means that the market is becoming a bit illiquid. So increasing the rates will either drive more deposit because, I don't know, you're earning more by depositing into that market, or it will incentivize borrowers to repay because now the borrower interest is quite high. So this is why the rate spikes here. Yeah. By the way, we can have questions along the way. Is that possible or? Yeah. Okay. It's across all markets. 190% is kind of arbitrary. We did simulations, etc., to find a good compromise. And 90% was the one that stood out. Yes. Yeah. You mean you? Yeah. So in the V2 that I'm not going to talk about today, we are going to provide. It will be a fixed rate, fixed term lending protocol, intent based. So you'll be able to say, oh, I want to borrow at X% over the next month, and whoever is willing to lend you at this rate, you will take your offer and lend to you. But it will be in the V2. Yeah, it's the current one. It's the current one, and I can dive into the V2 maybe at the end once because it benefits from all the learnings from the system that we are running today. Okay, let's continue. So this is the curve mechanism. It's quite simple. If the utilization move, I'm moving along that rate. There is another mechanism that is called adaptive mechanism. The reason we have that is, I don't know, let's say the Fed cut rates. How is it reflected on a market that is fully immutable? That's kind of hard, right? So the adaptive mechanism is here to have progressive adjustment depending on market conditions. So let's say the Fed has increased rates. Now that means that the demand let's say that utilization is high for a long period of time. That means that there's continuous demand. And maybe the rates, that the maximum rate is not reflecting a high enough rate to contain the demand. So what this mechanism will do, it's over time, the rate at 90%. So you have the utilization target that is at 90%. You have the rate target that could be 4%. If for instance, the utilization is at 100% for 1 or 2 weeks, this rate will the rate at 90% utilization will increase over time. And so basically moving the whole curve up. And you have the same mechanism. Let's say the utilization is quite low for a very long period of time. That means that there's basically there's low demand, or the rate is too high to create demand for that asset. So the interest rate curve will decrease. And that might trigger and incentivize more demand into that market. Yes. I don't have the formula. It's quite complicated, but a simple heuristic is if for 5 days the utilization is at 100%, the R target, we call that R target, will 2x. So and same thing is if the utilization is at 0 for 5 days, that means that the R target will be divided by 2 over 5 days. So let's say you have utilization at 100% for 10 days, it will 4x versus the initial utilization target, R target, sorry. So utilization is 90%, but the R target can be constantly moving, yes. It's really adapting on depending on market conditions. And that makes the whole thing fully automated, so we don't have to update manually those parameters. Liquidations, it's kind of basic system of liquidation. So you have, it's another collateralized protocol. So usually, let's say the LTV is 90%. What that means is if you have $100 as collateral, you can borrow up to $90. If the debt goes above $90, then you get liquidated. What liquidated means is someone will repay your loan, and this is the same amount of in terms of dollar of collateral plus a bonus. So in my example, I had like $91 of loans of debts. A liquidator will come, repay the $91 of USDC, for instance, and sees my BTC worth $91 plus a bonus. And this bonus is here to incentivize the liquidator because they're going to make money out of it. Else they won't do that job. And the bonus comes because it's over collateralized. So it could be $91 plus, like, I don't know, $4. Since I have $100 of collateral, that's fine. It works. So that's how liquidation works. We have this formula. So it's a bit complicated, but basically the liquidation incentive depends on what's the LTV at the market level. So the LTV, for instance, to remind you, is how much you can borrow against your collateral. So if it's 86%, you can borrow $86 against $100 maximum. And for this LTV, the liquidation incentive is 4.38%. The liquidations depends on the LTV, because usually the more the riskier the asset, the more volatile, the lower the LTV. The lower you want people to be able to borrow against their collateral, because it's riskier. And also the more you want, the bigger you want the incentives, so that you can incentivize liquidators faster, so they make the liquidation faster to clean the market. Because if you don't liquidate position in time, maybe you can create bad debt. Bad debt is the moment where there is a debt position, like someone who has borrowed, but now the collateral is not enough to cover the loan. So that could be, I don't know, someone who has $50 as collateral and $100 as loan asset. So that means that there's a hole, there's a gap, right? So liquidations are here to save lenders and to protect lenders against those bad debt events. Any question on this one? Oracle, Morpho is Oracle agnostic. So Chainlink can be used, PIF can be used, Redstone. It could be also hard-coded Oracle. Whatever can be plugged into Morpho. It just needs to have this interface at the smart contract level, which is very simple. It's basically pricing the Oracle asset in terms of the loan asset. This is a critical piece. Oracle usually is the source of many hacks in DeFi, especially in lending protocols, because if you can manipulate the Oracle, you can manipulate how much, for instance, you can borrow against your collateral. If you overvalue the collateral or undervalue the loan asset. So this is a critical piece of infrastructure. And so when a creator, I will talk about creation, when a creator is picking a market, is creating a market, the picking the right Oracle that is robust enough is one of the most critical steps. All right. I'm going to talk about vaults especially Vol V2. So I've been talking about markets that borrowers will interact with directly, but on the lending side, usually users, they don't want to select on which market. Right now there is maybe 1,000 markets on Morpho. So as a lender, I guess you don't really want to pick the right market on which you want to deposit. So what we've created is vaults that, in fact, are a smart contract where users will deposit liquidity into, and then there will be what we call a curator. It's a risk manager, basically, that is going to run that vault and decide on which markets to deposit those assets. And so it's really close to what we have in the TradFi ecosystem, where you have a saving account where you can earn yield, and that liquidity is put at work somewhere else. So it could be in structured products, in money market fund, individual bonds, etc. Here, the equivalent is using a vault as saving account, and then those loans will those deposits will feed some type of on-chain product that are fixed rate loans, credit, etc. You can see a vault as a sort of funds. The analogy is that vault curators are the new portfolio managers. They are allocates on-chain in lending markets instead of directly in credit, equity fund. Users retain custody of their assets, which is a distinction with funds. It's based on smart contract, so there's no or less manual process. You can automate a lot of things. It's accessible, transparent, etc. A vault, how does it work? Is so you have this vault that will allocate into different markets. Again, the user experience is you select. Yeah, sorry.
Just one thing, like about Vault Curator, like how do you manage the fact, like, because Vault Curators, the goal for them is probably to have like the best yield to have users depositing on the vault, right? But the problem is like then curators are like competing against each other, and so like I mean we saw some stuff of like Oracle pricing like that were like hard coded at like $1, and when you have like a stable coin depeggings and it's crashed the entire market and people can't withdraw the collat. So like does Morpho? I mean I know like Morpho is not like forbidding anyone to enter like as a vault curator, but like how do you manage this problem?
That's a good question. So just I provide more context. So a risk curator can set up a vault. Usually this vault will deposit liquidity into markets. A vault can target a specific risk profile. The cool thing about Morpho is then you can create many different vaults for the same asset, for instance, and you can create low risk vaults that are depositing in safe markets, and high risk, high rewards vaults that are depositing liquidity maybe in digital markets. This is what makes I think Morpho stand out compared to other lending venues, is then you can target different profiles, different persona, etc. But one side effect of this is you can have like really degen vaults, or some that won't be managed well if there's like a market crash, etc. And there's also a problematic where you need to how do you surface the information to users about where the vault is depositing the capital. So those are challenges that on our interface we show a lot of data, but maybe not enough. And right now we are working with Cordora, which is now owned by Redstone. They are here, and they are providing a risk rating for vaults. So in our interface, we want to stay neutral We don't want to be opinionated. We want to show all votes and all curators, even if like someone are way riskier than others. But we're going to display a risk rating in our interface to kind of provide a sense of which risk you are, as a user, you're taking when you deposit into that vault. So risk rating will be part of the equation. We are going to provide like much more data, but that means that we are going to part ways from a retail consumer app and maybe go more into the prosumer segment of users. Yes.
Yeah, I have two questions. So one is, what is the process of becoming a vault? Like, what is the criteria, conditions, and all those things? And do these vault creator have any skin in the game? Like, do they have to mandatory put something into this?
Some have skin in the game, some have not. Really depends on the creator. And the first, to answer the first question, setting a vault at the smart contract level is totally permissionless. There's a permissionless factory. So if you want to create a vault and manage for your own treasury or display that into your front end, you can do it. There's no problem with that. If you want to be listed in a Morpho interface, we submit a form, like we send a form, because we faced a lot of requests. It's taking time to list a vault, etc. And some are just like they want to create a vault, but it's not clear what they really want to do. So it's not that we want to gatekeep, but we just have the team is underwater. That's one reason. And the second thing is obviously we don't want to list them. So we can have that filtering system in place.
Got it. And maybe I have missed something. So this vault is basically take the money and invest into various product classes within the DeFi ecosystem.
It take the money and deposit that into Morpho markets, so that it earn yields because borrowers are paying interest when they borrow.
So among the various pools, these vault creators decide that which pool.
They decide in which market. So I don't know if there's a very safe vault, USDC vault, that deposit capital into only wrap staked ETH, WBTC and CPETH markets, and you'll have market that another vault for USDC, but that will deploy into PT tokens, Ethereum markets, etc. That are riskier, and those two vaults are completely isolated each other. So if something goes wrong on the PT market, it does not affect the safe vault.
So instead of selecting a one particular pool, vaults are like composable assets, and they take exposure into multiple pools.
Yeah, I can draw maybe. So if you, let's say you have those markets, those are buckets. It could be wrap staked if USDC.
So each market is each pool. Is it fair to say?
Yeah, we can say that. And PT, whatever, PT1, PT2, USDC. So the first asset is a collateral. The second one is the loan asset. And you could have one vault here that deposit liquidity into those two markets. You can have another vault that is riskier that deposits here. And you can have a third vault that deposits into
So as a lender, why can't I go directly into a particular pool rather than going through this vault?
That's a great question. So there's a few arguments. Is the creator will do reallocation of liquidity on the fly depending on market conditions. So as a lender, you don't have to bother about the price is crashing or there's a new opportunity, like a really huge rate on that market. Maybe I should reallocate more liquidity into that. The risk curator will do that job for you. So that's one thing.
And is it a true differentiate between like projects like Aave and all?
Sorry?
Is it a true differentiator between projects like Aave and all, where you have an opportunity to directly invest into a pool?
So Aave is kind of, if you compare to Aave, you would say that Aave is more like a one-size-fits-all model. that is centralized. So you'll have the DAO that decide on which asset can be listed in the pool. So it's not fully permissionless. It's not like fully decentralized. Morpho is more like free markets. So you can set up your own vault, you can set up your own markets, and so you can target different risk profile. So here you have low, here you have medium risk and high. On Aave, maybe you just have like the medium one because there's one pool with all the assets in that.
Got it.
So first argument is about market condition reallocation, real-time allocation depending on market conditions. So that's one thing.
And is it a full-time job which the vault creator is doing?
Yeah, this full-time job. They have like bots, reallocation bot that are running, and they can do also reallocate manually if it makes sense. If they've I don't know, maybe they are in touch with a large board. Let's say I want 100 mil on that market, then they could reallocate manually. Another thing is liquidity, because if you go directly at the market level like that, let's say someone, a very large borrower comes in and borrow all the liquidity on that market, maybe you would be stuck until you see the interest rate model, the interest will spike, etc. So that will drive repay or more deposit. But meanwhile, you can get stuck into that market for this the time being. Because the vault is depositing into other markets, maybe there's available liquidity here, or here, or here. So if you are at the vault level, you'll be able to tap into more liquidity. And so you could exit more. So that's another reason as well. To what? Yeah, they do the rebalancing. They do the rebalancing. So real time, there will be borrow here, land here, borrow here on all those markets. They will check the rates and they will see like a rebalance liquidity among those markets. I'm going to go into the different roles at the vault level. I think it can explain that actually. Let me. So on a vault, you have different roles. You have the owner that is basically owning the vault. It's the master admin. He managed like top level permissions, and he can appoint the curator and the sentinel roles. And the curator is basically the risk manager. It's the portfolio manager of the fund. It basically puts the bounds and the constraints within which the allocator, so the role that will allocate the liquidity depending on market conditions within the different markets. The allocator is appointed by the curator and will play within those constraints. And those constraints, I will talk about this, but it's basically like caps, exposure, maximum exposure to one specific market. So for instance, the curator can say, we can deposit 100 as much as we want in that market, but maximum 5% into this market because it's riskier. And the allocator can do whatever he wants, but within those bounds. He can't deposit 6% or more into that market. So curator is kind of like doing slow risk management, adding a new market, removing an existing market. And the allocator is more like the high frequency manager. Yes.
Sorry. Yeah. So if you have, I don't know, like you have like 100 millions like vaults, and like someone is withdrawing like 25 millions. I mean, if this is possible, like then like the percentage won't be correct, right? So like, is the allocator like forced to like readapt, or is it like
there's no like forced adaptation?
Okay. So
sorry, maybe I did not understand.
No, just like I mean, I don't know like if it forces like it triggers like kind of like not a liquidation, but like if it's like, because if it's a strict 5%, for example, and now because of this withdrawal you have like 10% or like 15% exposure to this thing.
Yeah, because of that. No, it won't trigger reallocation.
Okay, so but the allocator like should like over time.
Yeah, it should over time reallocate to go within those bounds.
I was curious, when you're creating a vault, how specific are the parameters that you're defining? So is it like I say my fee rate and I'm saying specifically the pools and how much I can go into? Is that the job of the allocator or the creator of the vault?
You don't have to select the markets in which to deposit at the beginning, but you select the name of the vault, the asset that you want to target. You can select all the time locks. So I've put like some functions like set owner, set curator, increase absolute cap, which is something that will increase the risk exposure of the user. So there's a time lock. Maybe you want a 7-day time lock for that. For some other like setting curator, maybe you want a time lock of 3 days instead. So you have granular management of everything that you can select the time locks at the creation of the vault. We have what we call the creator app, which is an interface that basically allows you to kind of update, manage, configure your vault the way you want. It's kind of the asset management 2.0 interface, something that you don't have in TradFi.
And is it basically that the user is ultimately trusting the allocator in order to make sure this vault stays solvent?
But you can always see the bounds that the creators have set. So you know that you as a user or a depositor into that vault, the allocator won't be able to go above those bounds. So you have like an on-chain like proof of the allocation that the vault could go. Yes, please.
I was asking, how does looping work? I mean, this is something that, of course.
So looping is more.
And how much of Morpho AUM is because of looping strategies that you got?
That's a good question. So looping is more on the borrow side, so not on the lending side. Vaults are lending specific. Borrow looping. I don't remember exactly the numbers. It's not that huge, to be honest, on Morpho, because on our interface we don't facilitate this. We did at some point, but we removed the features because it was adding more complexity engineering side. So there's not much looping actually. So you have all those roles. The allocator is the active portfolio manager. And you have the Sentinel, which is kind of the guardian of the vault. So for instance, let's say, I don't know, the creator does a mistake and wants to enable a too risky market or maybe a rug market. There will be the time lock, maybe a 7-day time lock, and the Sentinel can revoke that action. So it's kind of like a protecting users. So there could be different Sentinels. So it could be, for instance, I don't know, security partner like OpenZeppelin, Spearbit, etc. It could be Hypernative, which is a threat monitoring tool company that is offering those kind of service, and it could be, I don't know, like a DAO or whatever. There's also the adapter system. So Vault V2 is future-proof in a sense that instead of having the capacity to deploy only into Morpho V1 smart contract that we call Market V1, it can also deploy into Vault V1, Morpho Vault V1. It can deploy capital into Market V1 directly. And once Market V2 will be live, it will be able to deploy capital to those Market V2. And if there is V3, V4, we'll still be able to add those adapters to the different Vault V2. And it's the curator that decides whether they want to add that adapter or not. Yes. Sorry.
In case of like a smart contract breach, like I don't know, sometimes you see like balancer, like I guess it was a V2 act or something like that, but V3 was not affected. So which is like propagator risk.
You could kill the adapter. So for instance, let's say we are at the V3. Most of the activities on V3. And V1, there's basically not no liquidity anymore. Then you can just remove the adapter. Like you can reallocate all the liquidity to V2 or V3, and you could remove those adapters and cut your exposure to those markets.
Okay, but as long as they are enabled, technically you can have an attack vector, right?
If you set the cap. To like you could have an adapter that is listed but capped to 0.
So you can cap the adapter, yeah.
Unless there's an issue I'm not aware of, but if the cap is 0 and you still have the adapter, that should be fine.
Okay, thank you.
So here's it's the cap system works with ideas. So for instance, an ID will be the representation of a market. So you can set a cap for each specific ID. And what it allows to do is, before I said, oh, you can allocate to two different markets and set caps for those markets. But you can also define a risk exposure for an asset. So it could be here, you have wrap stake TIF, USDC, but with another LTV and another type of oracle, you can say, I want a maximum exposure to 30% of all my funds that are in the vaults to that specific asset. So you can be very granular into the risk exposure. So you have a scalable way to do risk management, which will be super important for Market V2 when it's live. I don't know who talked about fees. It was the question about the configuration of the vault, but there's two types of fees. There's the performance fee and the management fee at the vault level. So performance fee is basically you take a cut on the interest rate that is generated. And management fee is basically on the AUM. So I don't know if it's, there's 100 mil, you take 2% maximum of that. And there's a performance fee at the market level as well. A vault is at any time non-custodial. So what that means is that a user can always exit the vault. It depends on the configuration of the vault, though. But by default, a vault can be configured to be non-custodial, which is not something that you have on overlanding venues, because overlanding venues can pause and upgrade the smart contract. So you could lose your funds if there's a mistake that is being made. On a vault, we have something that we call in-kind redemption, where let's say you have a position on a vault. So this vault, you can exit the vault, even if there's not liquidity available at the market level, you can end up with position at the market level. So instead of now having the, I don't know if it's a vault, you have the vault token in your wallet, you could exit and end up with direct position at the market level. So that's one way to exit the vault, and the time lock and the separation of roles enable that non-custodiality, which is super important if you want to create a non-custodial product. So some case studies, a bank is using Morpho to power their stablecoin. So for instance, this is Société Générale is a very large French bank. They have like the traditional lending system that is working, and they are expanding their their lending capacity into the DeFi world through Morpho loans. So they have a stablecoin that is called EuroCV, and they have created markets on Morpho. There's a vault. There's 2 vaults for EuroCV, and those vaults are being integrated by centralized exchange, European centralized exchange that want to offer yield product on top of euro. So they have users, they want to earn like 5-6% on euro. They are going to integrate those vaults into their interface so that in one click, their user will be able to earn 5-6%, something that you can't get really easily using TradFi rails, even via existing fintechs. There's Fenbushi Capital and Steakhouse. Yeah. And they launched recently, so yeah, it's getting started. Coinbase loans. So Coinbase integrated Morpho. Integrated Morpho as backend. So basically, they have a loan product. So where you can borrow USDC against Bitcoin. So it's CBBTC. So it's the wrap BTC version of Bitcoin. There's, I think, 1.5 billion of collateral, 900 millions of USDC loans. And basically, if you have the Coinbase main app and you're a US citizen, it's not yet accessible in Europe or what. But if you're a US citizen, you can go to the Coinbase main app and borrow in one click against your Bitcoin. And there's the other side, which is the lending side, where you can lend USDC, and lending USDC will basically feed the borrow demand. So you can earn like, I don't know, maybe 7% on your USDC on Morpho. And there's, yeah. So now this integration is multi-billion integration. And a lot of fintechs are trying to reproduce that product, because here Coinbase own everything from top to bottom, because it's immutable smart contract. The Morpho governance cannot change the risk parameters. They cannot change the product. So they own everything. And it allows them to create a very tailored product. So there was one question there.
Of Coinbase and also, the previous Society General, these are like financial institute. Now Coinbase is almost a financial institute. So how they can participate in the Morpho ecosystem, more like a distributor or a vault creator or supplying the asset?
So here Coinbase has selected an existing vault, and there are basically Coinbase will sit here. They have it's the Coinbase CB main app. And here it's routing the liquidity here, for instance.
Okay,
and
so more like a distribution pulling more liquidity.
It's more a distribution partner. But yeah, it's more a distribution partner. They leverage the Morpho infrastructure as a backend.
Okay, and how about Society General? Where does it fit? More like supplying the asset, or
so they do both. There's the lend product, and there is also the borrow product where user can borrow, and it's a CBIF. CBBTC, sorry. They can borrow CBBTC.
So this is more like an RWA asset?
No, it's CBBTC is the wrap version of Bitcoin. So
okay.
The users have Bitcoin on the centralized account, a Coinbase centralized account. You have Bitcoin. They allow their users to actually borrow against the Bitcoin, because a lot of Bitcoin holders actually can't do anything on chain with that. There is a huge demand though to borrow against that, and Coinbase is adoring this on top of it.
Are there RWA projects are also coming from a supply side, like from asset supply side?
There's a lot of market with real world asset as collateral. It's representing hundreds of millions on Morpho right now. But Coinbase has not integrated that yet into the borrow product, for instance. Yes.
What's Morpho's take on most of the vaults, and are these case studies with like Coinbase and SC General? Is that the same Society General? Sorry, is it the same take rate, or do they have a different take?
It really depends. There's some vaults take 0% fee. I think the what do we think about the creators? You mean? No. What is your take? So you offer this service. They're using your service. What is your take? So we think that the Vault is asset curation, asset management 2.0. It's the future of asset management. So what we're going to see is larger asset manager coming on chain, and they're going to manage a vault because, as I said, I had a slide on what's asset management. I mean, what's managing a fund. We can take rate at the market level. Yeah, it's performance fee at the market level. Yes.
Hello. I want to start my own curator. I have liquid strategies. I have liquidity. Which steps? Which requirements?
Read the doc. Read the documentation. Understand how Morpho works. Deeply understand how Vaults works. And then there's the Creator app that can be freely used by anyone to set up a vault. And then after, like, to be listed in an interface, it will require more work because you need to prove that you have significant track
It's
record.
like KYB or some traction.
We don't do this. It's more about credibility and what's your growth path that you envision, etc. Because we have so many demands that we just don't have the bandwidth to, if it's too small. But that does not prevent you to create the vault and distribute that. If you have your own interface or your own clients, you can like create your interface and say, hey guys, deposit into that vault.
Yeah, we plan to explore yield basis markets. Yeah, you know, take loans using yield basis collateral.
Okay, I see.
On Bitcoin.
You can do that.
Yeah. Thanks, man.
Yeah, I think it's the last slide. So another example is Lemon, which is South American fintech, and that is providing an earned product on top of Morpho against USDT mainly, but over stablecoin assets as well. So yeah, that's the kind of product that you can create on top of Morpho. And I think we are kind of out of time. 1 minute. Okay. One question. There's no question. Then we can wrap up. Okay, cool. Thanks, everyone.
Thank you. Today, I'm going to be mainly talking to you about our product for securing rollups. We developed essentially a new, well, let's talk about the stack first. So what is Boundless? Essentially, we are chain agnostic. We're a set of smart contracts that enable provers and proof requesters to find a match on chain. These contracts can be deployed on any EVM compatible chain. Currently, we are running on Base mainnet. The stack also allows provers to run a fully distributed prover using multiple machines. And our network is also special in the sense that we have a proof of verifiable work mechanism whereby we use that to subsidize the cost of proving on the network. So as long as someone is proving using the ZK VM, they're able to take a proof of all of the work that they have done and mint a coin in exchange for that work. And the core of all this is the ZK VM developed by RiskZero. Originally, Boundless spun out of RiskZero, but now we're like completely independent. So what is our product for rollups? We have all of this great proving power. We literally have enough capacity in the network to prove 28 Ethereums. If you've kept up on Twitter recently, our network has done over a quintillion cycles in the last epoch. An epoch is about 2 days, which is enough to prove several million Ethereum blocks. So we mainly developed a product for proving rollups in both fraud-proof mode and for full ZK validity mode. Our offering is kind of unique in many ways. In the fraud-proof mode, we've basically developed the only non-interactive dispute game out there. And I'll explain what that gives you essentially shortly. But we also give you a hybrid approach whereby you can run in optimistic mode or fraud-proof mode by default. And if you want to fast forward the finality of your rollup, who here is unfamiliar with how a rollup operates, or would like me to elaborate on that? All right. Yes, elaborate. Okay, so a rollup essentially is a. You can. Huh? Yeah. Going? Nope. Cool. So a full ZK rollup essentially is something you run in full ZK, and our hybrid approach allows you to just run in optimistic mode and use full ZK whenever you feel like the cost is right or the time is right or you want the faster finality without any configuration changes, essentially. So to talk more about that, we basically improve upon the basic optimistic rollup mode. Instead of running like an interactive dispute where there are a lot of transactions for a back and forth, if some malicious proposal is posted, we just wait for proofs to come in and settle any outstanding disputes. So all you have to do, like as an honest proposer for a rollup, is just make the honest proposal, no proofs yet, and by doing that, you've guaranteed the chain's safety. Because as long as there are any conflicting proposals, then ZK proofs have to come in and show which proposals are bad, or show which proposal is right, and automatically just delete or omit anything that is considered bad. This means that you just need one transaction every challenge period to guarantee that your rollup is safe, which is not true for any other system. There are ZK fraud-proof games where the model is sort of different, where someone makes a proposal and still someone has to challenge that proposal, right? This doesn't give you the same guarantee because you have to run after each bad proposal and challenge it. So you're still open to someone having more collateral than you, making a lot of proposals, and you're not able to challenge them. Whereas in this model, you just have to make the honest proposal. That's it, and you've guaranteed safety. So this means that your requirement for protecting your rollup, no matter how much money your adversary has, is constant, right? And it can be a very low constant, because all you have to cover, all that collateral has to cover, is just the cost of a single fraud proof. And that proof will just remove all of your proposals as of the first bad one you make. So you just put up collateral to become a proposer, and then you can do what you want. Whereas in other models, you have to put up collateral per proposal that you make. So, currently this is the best way to sort of transition slowly to full ZK mode, because you can start off in a model where you've set up your stack to employ any potential ZK proving when needed. And again, when the time is right, you can just turn on full validity mode and fast forward your finality. There's also like a hot debate going on right now about whether you can reduce the 7-day challenge period or not. There seems to be some agreement that if you just have to do a single transaction, a day is enough. So this puts fraud proofs in Kailua in a very unique position for that sort of thing. Right, so how does this actually work? It's a lot of logic under the hood, right? Just having to do one honest transaction every period. It works because there's a lot more structure in our game for each proposal. So normally in a rollup state update proposal, you just submit a claim of what the state of the latest state is, right? You don't say anything about how that claim relates to prior claims. Some fraud-proof mechanisms make use of combining these statements so that they compound on each other, and that does a good job of reducing the collateral requirements to a certain extent. But the structure within Kailua is much more involved. You basically say that a statement is a child of a previous one, and so the validity of like all the proposals are contingent on their parents being valid. And then this allows you to sort of pause everything if there are contradictions, right? And then wait for the ZK proofs to come in. And the collateral requirements are then substantially reduced. It's no longer that you should have potentially millions in Ethereum to play the interactive dispute game. You just have like 1 ETH be the requirement, not because proving will cost you 1 ETH if you have a fraud proof, but just because you also don't want the requirement to be so low that someone's just gonna mess with your rollup in one way or the other, right? It's an interesting trade-off between having a very low barrier to entry in your fraud-proof mechanism, where you could be fully open to anyone challenging your rollup in several ways, but you don't want to make it practically cost-free, so that it's not just annoying, right? And feel free to interrupt me at any point for any questions. So this is the structure I was mentioning, essentially, right? If we start from proposal A is like the last state of the rollup, and we have all of this tree of proposals that all depend on each other. In this state, like all of these B's are contradictory, and we either need to prove that the correct B is actually correct, or prove that these two other B's are incorrect. And if we choose to go down the fraud-proof mode way, where we just prove something is incorrect, we can have an advantage there, because you don't have to like the proposal could cover a very huge transition. Let's say it's several thousand blocks, right? But in Kailua, we also allow you to not only submit the final state of that transition or the final result, we also let you use blob data to also commit to intermediate states. So, for example, you submit a single transaction on chain that has a blob associated with it, which can carry 4,096 commitments. And if every proposal is about 4,000 blocks, then you can essentially have your fraud proofs just cover a single transition of 1 block. And that is much more cost efficient and much faster to compute. It is effectively a few billion cycles at most, even if you have like very high gas costs. And what that translates to is that it's like $1 or $2 improving costs on commercial hardware. Good so far? Yeah. Right. So, yeah, I keep jumping ahead of the slides each time. So this is what I was mentioning. But how would you actually decide this collateral, right? You need a number that isn't a very low barrier to entry that you get spammed, but you also need a minimum number that actually covers the worst possible case. We've all heard of, prover killers and these ways to construct blocks that can be difficult to prove, or maybe sometimes impossible to prove in some ZK VMs. And that is essentially should be the minimum bar for your collateral. But even then, this is mainly built for the risk zero ZK VM right now, where there's no unprovable block, essentially, because you can just execute for as long as you need. But also accounting for a model where not only is a block malicious, like an L2 block is malicious, you also have to account for a case where the rollup operator has also a very large pool of funds available to them so that they can spam the entire parent chain or L1 Ethereum with a lot of data that would make deriving the L2 data also very expensive, substantially expensive. Let's say they just spam the L1 chain with blobs for an entire day. So even under those costs, assuming they have the budget to do that, you would not need a substantial collateral amount to do it. 1 ETH actually would cover it under very reasonable configurations that are live today in deployment. For example, we have the build on Bitcoin mainnet using Kailua in production today in fraud-proof mode. And the bond over there is only half an Ethereum, just based on multiplying like the minimum collateral by a factor of 4 or 5. So it can be made, it's very effective at reducing collateral requirements, so you can have a great security budget. And at such a small cost, you don't even have to worry about how much an attacker has to spend to take you down. They can spend as much as they want, but you just have to operate normally to defeat their attack. We also have something kind of different called Vanguard mode. So as I mentioned, as long as you're doing the honest proposal, you're guaranteeing the safety of your rollup, right? And most rollups today have a very well-known, they have a centralized sequencer, essentially, like a known entity that operates the rollup. And what Vanguard mode allows is that they get to make the first proposal for any given block height, right? And then people can make alternative counter proposals to challenge them or to guide the rollup towards the right way. But Vanguard mode is mostly useful for ensuring that if that rollup operator is honest, then you have guaranteed safety of your rollup because they get to always make the first proposal. If they make it right, it doesn't matter what happens afterwards. It doesn't matter how many proposals come in afterwards. Even if there is censorship on the L1 for, let's say, 30 days, not even just 7, right? They will still be able to do the first proposal and guarantee the safety. So it comes with a timeout period, of course, so that if they go completely offline, then after this timeout period, anyone can make like that first proposal and more proposals can come in. And this is important, again, for the cost factor, because there could be significant congestion on the L1, preventing the rollup operator from making the right proposal. They could have been taken offline for any reason due to infrastructure or some attack. And Vanguard mode really gives them very good security posture and that they can guarantee that the right proposal will be made first. And because of the properties of the remainder of the protocol, it doesn't matter what anyone else does afterwards. The ZK proofs will just come in to, sweep away the fraud. Yeah.
I think I'm a bit confused now. So the way I understand it is like it feels like there's a mixture between optimistic and ZK rollup, right? So could you maybe walk again? Like when does the ZK thing kick in? Because you say like, okay, as long as you do the honest vote, then whatever is fine. So it seems like you do not need to. When you make this statement, it feels like you don't need the ZK or you don't need optimistic. So like when does each part kicks in? So like that.
So the ZK kicks in when there is a dispute or a conflict between different proposals. So to elaborate, let's say I am the rollup operator. I say that the rollup is at a certain state at block 100, and then someone disagrees. So they say that no, the state is actually different at block 100, right? At that point in time, there is a conflict between these two proposals, and the ZK needs to kick in, meaning that a proof needs to come in to either disqualify one of these proposals through a fraud proof or prove one of these proposals correct through a validity proof. So the ZK in fraud proof mode only needs to kick in if there's a conflict on what the state of the rollup is. someone is being fraudulent, essentially. It can also kick in if you just want to fast forward the finality of the rollup. So you don't want to wait for 1 day, for example, for the claim that someone had made about the state of the rollup to be accepted. You want it done in an hour. So you just generate a validity proof of that claim and publish it to automatically say, we don't have to wait the full period for this. We can just accept this now, meaning that the withdrawals that are waiting based on this claim can be executed. And in this context, safety essentially means that no bad withdrawal, meaning no withdrawal that leverages a bad claim, can be finalized. So funds still remain in the rollup. Liveness is essentially that every withdrawal that uses a good claim can eventually be finalized. And you need both for things to make sense.
So is this saying that in the happy case, there is not going to be any ZK in any challenge or optimist? Just it's like if right, in the happy case is none of them just matters, right? It only kicks in at the bad times.
The proving only in fraud proof mode, yeah. In the happy case, no proving happens.
And typically, we should assume that just even for optimistic ones, if it's happy case, the dispute does kick in, so the challenge or whatever also doesn't kick in.
Right, but if they're not backed by ZK proofs, so a lot of the reasoning of why you can just pause everything if there is a conflict is because you know that the proof is just going to be a single operation that just shows immediately who is right and who is wrong. With like every other interactive protocol right now, you essentially you need a back and forth between these parties to eventually reach a conclusion about who is right and who is wrong. So that allows, the non-interaction, the one shot of the ZK proof allows you to basically allow, pausing finality safely until these proofs resolve the issue without any, I challenge this, I respond here, and any of that. And that's why you can just that's why you're able to be safe against whale attacks. Like you're not afraid of being dragged into all of these back and forth interactions with the adversary. You just do your claim, you operate normally, honestly, and it doesn't matter what your attacker does. You know that eventually these ZK proofs can eliminate all of their moves. You don't have to chase after them. And yeah, this is what I was referring to, liveness through proving. So when there is a dispute happening, right, and everything is on pause, you do need these proofs to come in to allow the honest proposals to go through and the withdrawals that are based on these honest proposals to also be processed. So you might also be thinking someone could make a very large amount of identities and use those to submit a very large number of proposals, eventually forcing you to create a substantial amount of fraud proofs to take them down. So there could be like no bound on how much proving you need to do, but because you can also, instead of proving all the bad claims as bad, you can instead just prove the good claim as correct and then automatically disqualify all of these bad claims. So you always have an upper bound on how much you need to prove to guarantee aliveness, which is essentially validity proving. And even if the attacker attempts to put you in that scenario, it means that they have put so much collateral at stake to subsidize the cost of your proving by orders of magnitude, essentially, because they've put up a piece of collateral for each block that they have misproposed. So the asymmetry between you and the attacker in terms of collateral is incredibly magnified. So you also don't have to worry about creating these proofs, right? We at Boundless have done a very good job of making these numbers basically outdated, right, since 2 days ago, right? There's a lot of capacity on the Boundless network, as I previously mentioned. We've done about a quintillion cycles in the last epoch, which means you can prove 28 Ethereums just running with all of that. And the cost of proving essentially on the network is 7 times less than the next biggest network. While the number of cycles processed is effectively 90 times more. So all of this is basically backed by the ZKC coin, right, which allows all these provers to receive a reward in exchange for all the proving that they're doing, and for the users to also not pay as much without it. So we're also looking forward to onboarding several more partners in full validity mode and in full fraud proof mode for fraud proving. Whereas the people in fraud proof mode just leverage the fact that it's very reliable to get your proof filled right now. We're also always improving that. So when fraud does happen, you're not going to wait for hours for it to be resolved. You specify like your proving parameters, and it can be resolved in a few minutes, essentially. While validity proof mode can just keep up with your chain as it is being created. It can be proven somewhat in real time, but just using batching. So instead of having a proof every block, you would maybe have a single proof every 100 blocks or so. And all of this is live on base mainnet. You just request the proofs essentially on base mainnet, but you can use them anywhere else, right? We have verifiers on Solana, for example, and on a lot of EVM chains. And I think we're doing pretty well on time. If anyone has any more questions. We're actually very good on time. All right. Thank you, guys.
All right, next we have Carson, who is the senior project manager of Gauntlet, which is a BTC yield landscape. Please welcome Carson.
Thank you, everyone. Yeah, just quick summary. I'm a senior product manager at Gauntlet, who is, Gauntlet, we do a bunch of different stuff. Most notably known for risk management on chain and a lot of vault curation across the space. Gauntlet's been around for like 8 or 9 years at this point. We've seen everything. We have experience with everything. But today I'm talking about what I'm calling yield of BTC and the stable coinification of everything. Quick summary, who am I? As I mentioned, senior product manager at Gauntlet, currently focused on vault strategies, but I've really worked across every single type of client and project that you can think of that Gauntlet has touched. I've worked on lending, perps, restaking, and before that, I spent 2 years at 21 Shares, working ETFs, getting asked hard-hitting questions like, can you design an ETF that does that crypto stuff? Which was a quite frequent question at a ETF company that happened to do crypto. And on the side, love on-chain data and Dune. So quickly want to break down what we're seeing right now in the yield landscape in crypto. And I'd like to break this down by generally these kind of core yield primitives that we see across the space. Biggest one, obviously, is going to be lending. It's going to be your Morpho, Euler, Compound Ave Fluid. Obviously, you're all familiar with the large lending platforms in DeFi. This represents about 65 billion in TVL. Staking and restaking. Obviously, direct staking is a massive driver of TVL. We have Lido, Eigenlayer, Symbiotic, Rocket Pool. We have LPing or liquidity providing. So this is DEX LPing. We have perps LPing kind of blowing up recently. HLP, LLP, JLP, bridge LP positions. And where we've seen a ton of growth over the last few years is tokenized trading strategies. So your Athena, Syrup, Resolve. This is kind of back to the stable coinification of everything. Of like, it doesn't really matter what you're trying to do. You're wrapping it in a stable coin. It's just the form factor of distribution of preference these days. And lastly, we have RWAs. But if we look at it, the space is really coalescing to USD denominated yield. So if we look at lending on stables, ETH and BTC, lending stables is going to get you anywhere from 4 to 9%. Bitcoin, you're never going to be breaking 10 bips. ETH, you're basically just up against the staking rate. And same goes for staking. So ETH staking, you're at about 2.6 when I put this together. Bitcoin, obviously Babylon exists. You're in less than 1%. You have volatile LP positions. Then from a tokenized trading strategy perspective, you're not really getting much, right? Athena, these guys, Syrup, Resolve, it's all USD denominated. So tokenized trading strategies are getting you 4 to 10%. Nothing exists for ETH, nothing exists for BTC. RWAs, same story. Everything is USD denominated, nothing for ETH, nothing for BTC. But the BTC yield landscape is certainly heating up. I would say Babylon peaked at 63 million BTC staked, really validating the demand for native BTC. We see wrap BTC dominance at an all-time low. BTC is overtaking TVL on some chains, and we see more tail issuers coming in, all really competing here on yield. This is your LBTCs, UniBTCs, FBTCs. Everyone knows them. They've gotten louder recently. Wrap BTC has kind of stayed relatively flat. And generally, when I think about these like kind of wrappers, you're competing on two things, liquidity and yield. If you think about ETH staking and LSTs, who ended up winning? Lido. Everyone generally had the same yield profile. And when everyone has the same yield profile, you're always just going to end up centralizing to the most liquid solution. Same exact thing happened with LRTs, right? I think people were excited for LRTs because you were supposed to have a diversity of risk exposure. And from there, you had diversity on liquidity and risk. But without much slashing risk and restaking, all the TVL ended up concentrating to EtherFi as the most liquid solution. And that was really it, right? So as these BTC wrappers come in, obviously they're competing on liquidity, but competing on yield is really where we're seeing a lot of discussions heat up. So what's going well? Obviously, everyone wants Bitcoin yield. There is no Bitcoin yield other than LPing. But what is going well is that we are seeing really lower bar rates against BTC wrappers because of more and more lending platforms taking segregated market approaches. If we look at this is just a screenshot I took from Morpho recently. Bar rate for USDC against BTC is around 4% for wrap BTC and CBBTC. At the time, it was a little around 5.5% on Aave. And that's really because the segregation of these markets allow for people to have preference to only lend against their preferred blue chip collaterals, which with BTC is one. And with that, we're seeing kind of lower than ever, not lower than ever, but lower compared to the market BTC borrow rates compared to the rest of the yield landscape. And so with that, we get into essentially carry trades. So we come back here. Obviously, you can get yield on BTC by running LP strategies. There's more diverse stuff coming online. Obviously, CME launching Bitcoin futures has introduced a lot of off-chain strategies, perp strategies, and such. But in terms of your DeFi native strategies, to get access, the only option you really have is running a carry trade. And you're taking advantage of these lower borrow rates against BTC and the growing kind of landscape of stablecoin yield strategies to squeeze out additional yield into your BTC. We're seeing a massive growth in types of products like this, actually. I think when you come into evaluating a carry trade, obviously in DeFi, people love just seeing the big number. So that's where I'm going to put my BTC. But when you're putting together one of these carry trades, there's really a lot of core verticals that need to be considered outside of just what is my overall return. So when you look at this, generally you have your overall APY. This is going to be your position LTV times your stablecoin yield APY minus your borrow rate. You have a drawdown to liquidation. Then you have a strategy duration. So what is the time from when my redemption is filled to when my redemption is requested for my underlying yield strategy? I think overall, one of my other things I've been saying for a while, composability in DeFi is basically dying. Like everyone's getting pretty comfortable with non-atomic issuance and redemption cycles. Going back to these tokenized trading strategies, Athena, Athena, Syrup Resolve, all have non-atomic redemptions, some have non-atomic issuance. Obviously, they have on-chain liquidity, but it's hard to build massive strategies around those. And frankly, that's fine. And obviously, RWAs are growing as well. But it is something that now, coming into these carry trades, needs to be considered. Your strategy duration. So, for example, here, if we have two different strategies, one yielding 12%, one yielding 9%, but we have a 9% strategy with instant liquidity. This can just be standard lending compared to a strategy yielding 12% on a 24-hour redemption timeline. This could be one of your preferred wrapped basis trade products. With that in mind, you now need to kind of consider how you set that LTV where you're borrowing in your carry trade position. So, for example, at a LTV of 86, so in a 24-hour redemption, I mean, we've seen Bitcoin drawdowns in excess of 20% in a single day, quite frequently, really. I mean, over the last few years. So if you know you're not going to be able to get out of your position within 24 hours, assuming you even request it as soon as you detect a drawdown in BTC, you'd want to set a conservative LTV at around 50%. Alternatively, at a 9% strategy with instant liquidity, you can set a much more aggressive LTV, maybe near 80%, where your drawdown to liquidation is much lower, around probably around 6 to 7%. And as long as you have the on-chain automation to respond quickly, you can end up outperforming on a Bitcoin yield sense as compared to the higher yielding stablecoin strategy when accounting for the fact that you can take a higher LTV. I think this is generally where I have been seeing a ton of new projects entering the space is how can we reintroduce liquidity to these non-atomic assets? Obviously, we do a lot of work on the RWA side. These products have cycles and quarterly redemptions. And it's really a space that we're seeing a lot of people building, hoping to bring additional liquidity into these RWAs. It's something that I think is going to actually massively blow up the Bitcoin yield space. I would also say this isn't really Bitcoin specific. Frankly, like staked ETH looks a lot like Bitcoin in the sense of there aren't really many yield opportunities beyond the staking rate. And so I think as we see more carry trades enter, all these kind of illiquid tokens, or not illiquid, but non-yield generating tokens are going to end up being funneled into these kind of carry trade universe. So how do you design a Bitcoin strategy? I'll throw a name up there, crossed it out. Who knows what's coming? But at first, it's really about focusing on liquidity first. I think generally everyone wants to hit the market with the highest yielding strategy. Thing on my side that is the highest focus is hitting the market with the most liquid strategy. Until you have significant size, it's really not going to make sense to diversify your borrow position into illiquid positions until you can get some size there and have some guarantees around the redemption durations of your depositors. So it's liquidity above yield as long as you're beating that borrow rate. And again, as borrow rates against Bitcoin have come down, there's a lot of accessible ways to do that. After that, you get into essentially expanding your strategy universe into longer duration positions. You kind of think about your portfolio of stablecoin yield positions primarily on duration, with prioritization based on duration instead of just yield. And then eventually you just kind of tranche it out, right? There's a massive audience of low risk Bitcoin whales. Going back to Babylon, right? They peaked at around 63 million BTC. And that was recently. That was really a month ago. And so obviously people are comfortable with staking, whether or not it's real staking, who knows? But obviously there's an appetite for this low risk staking. So how do you kind of bring that to people when carry trades are introducing quite significant risks, really? Like there's liquidation risk that you cannot avoid. So you got to tranche these things out. First loss, second loss, and finally iterate, manage risk, do it again, add more strategies, do it for your next favorite vault product. And that's about it. Any questions?
With real world assets coming on chain, so you're dealing with something that's, U.S. market hours. How do you handle, or how are you guys looking at, I guess, the liquidity mismatch between something that's 24/7 and something that's like 8?
It's something we've talked about a lot, right? Like, especially with you're seeing a ton of tokenized equities coming on, and some of them will trade 24/5, right? But if you have, obviously, we do a lot of work on Morpho. Like, if you're trusting liquidators who are going to liquidate this position 5 days a week, that's not really good enough. And so, luckily, the only thing with a lot of these RWAs is even if the redemptions do not trade during market hours, the prices, the oracles are generally not updating as well. So there's low risk of volatility, but obviously you still have interest rate volatility on the borrow side. So generally what we're looking at is like short-term liquidity solutions. So you have lines of credit with market makers, but you're seeing a lot of interesting protocols come online as well. Cap, if you're familiar, they're doing like offering these line of credit products. I think you're going to see a lot of stuff end up using those cap vaults as lines of credit during these kind of like duration mismatch periods. Yeah, essentially. And we've actually talked to a lot of people raising funds to just be warehouse facilities that buy these things. Yeah. For pretty, across pretty sizable durations. I mean, I think like 7-day exposure for DeFi is like, some people are familiar with it. Some of these things are getting to like quarterly. And at that point, it's just all market maker agreements. But there's some warehouse facilities coming online that are interested in buying these quarterly positions. I think what people are coming around to getting comfortable with is it is very, very expensive to sell an illiquid position. And yeah, I've talked to some teams looking for like sub 1% spread. Not going to happen. Like most people are quoting you above 20%, 30% for an illiquid position. So at that point, it's really about making sure your liquidation bonuses are set appropriately if there's any lending in that use case, or just not putting leverage on.
Yes. So with regards to yield on Bitcoin, what do you think is missing aside from the most obvious opportunities for Bitcoin DeFi, given it's a much more liquid asset than ETH, to really catch up to, yield on ETH, for example?
Staking, like some type of scalable staking infrastructure for Bitcoin. I think the tough part there, obviously, there's a ton of Bitcoin L2s. I think, obviously, Babylon coming online trying to do stuff like that as well. But the interoperability is tough. Like, you have to scale now in L2. I think the nice thing about ETH staking is most people are still on a EVM chain that's benefiting from the ETH staking, so it's quite digestible. Bitcoin staking really only makes sense for most people if they're active on that Bitcoin L2. So finding ways to bring Bitcoin staking to Ethereum would be great. And then like some lower risk strategies as well.
Do you see an opportunity for like tokenized trading strategies on Bitcoin being on chain at some point? Or?
Yeah, absolutely. My only thing is I think most of these tokenized trading strategies are going to be taking advantage of USD denominated tokenized strategies, would be my like theory. So you can get a wrapper. I guess my concern there would be like on a lending side, right? If you have a tokenized Bitcoin yield strategy that under the hood is actually borrowing against your Bitcoin, doing one of these carry trades, as DeFi does, it's going to get wrapped into a yield-bearing Bitcoin asset, and people are going to like lever it as high as they can go. And at that point, you're kind of like doubling your exposure because you have a loan underlying this position. You're taking an additional loan on top of that. Obviously, stuff like this happens all the time. So I think there would be appetite and growth for it. It would be the one thing that would concern me there is pretty high risk. And
I wanted to, can you explain the numbers on the carry trade slide where you went?
Oh, I mean, yeah, all I was really trying to say here is like, okay, your overall APY for a lower yielding position, a stablecoin strategy position, can be higher for
the overall API is for whom? On
the Bitcoin level.
Yeah, on the
collateral
on the
asset side.
Provider.
Yeah, on your realized asset side, because assuming that your LTV is set appropriately with regards to your liquidity duration, then the instant liquidity enables a higher LTV, which enables a higher APY. Obviously, you could throw all this out the window and cross your fingers.
The strategy API is where you're deploying the money.
Yeah,
That's yielding 12,
yes,
9%, right?
Exactly.
And you're borrowing at whatever LTV 50,
3%.
It's returning 4.5. So 4.5, 4.8 is actually getting returned to the collateral provider.
Yeah.
Right.
Yeah.
Yeah. And this strategy is how do you take care of price risk of collateral, interest rate risk? Because most of these strategy deployments that are happening on Morpho, for example, I asked somebody how to take care of interest rate risk because.
No, well, that's generally why you have to set this LTV appropriately with your liquidity. It's like generally, even if you're polling all of these parameters on a minute by minute basis, if your liquidity is a 24-hour lockup and you can't really respond to those scenarios, you just always need to assume worst case and then set that LTV appropriately to that worst case scenario. So if utilization goes to 100%, my borrow rate is, 30%, and I need 24 hours to repay my debt, how do I set my LTV to make sure that in that worst case scenario, and let's add a Bitcoin drawdown to that as well, I am covered in most cases. Obviously, if Bitcoin gets zero, then you're screwed, or there's a massive flash crash. But most Oracle providers right now have a price update threshold. I would also say for the most part, there's quite a few events where price updates are outside the bounds of their threshold parameters. So historical events do not predict future events. But yeah.
Just quick question. So I found the talk pretty informative. Is there any way that you have any write-up on this so that I can go back or? Oh, okay, good.
I can also just send it to you. Yeah. We'll have some docs on this non-existent product shortly. So, cool. Thanks, everyone.
Next, we have Curve. Alberto is a core dev at Curve, and he is here to talk to us, give us a deep dive into the Curve tech stack. Curve Finance is a DEX optimized for low slippage swaps between stablecoins and similar assets that peg at the same value. So please welcome Alberto.
Hello, everyone. How are you guys doing? I wanted to just check quickly, how many here are devs or technical people? Good. The ratio is there because it's going to be an interesting conversation otherwise. Okay. So today we'll be covering a bit our tech stack because we use something completely different from the rest of the industry, I would say. Like maybe there are some other projects using Viper, but for sure we are by far the only one using Titanoboa. I also want to give you a high-level overview of the Curve smart contracts and try to demystify that a bit because I feel like we have built across 5 years quite a lot of stuff and not everyone really understands it, rightfully so. And yeah, our direction for the future engineering-wise. So yeah, let's start with Viper. Who has ever tried Viper in the room? Okay, actually nice, 2 people. Viper history in a nutshell. So it used to be a toy project from Vitalik back in a very long time ago. I think it wasn't even called Viper anymore. It was Serpent or something. Over the years, it changed quite a few maintainers. And at some point, it was also commented by Curve because we really wanted to stick to Viper. Because it also, for example, among the many perks, it has it had a Python-like syntax, so it basically made it much easier to write heavy math on it. But now Viper is an independent project and it's never looked better. It's much more production ready than it was before because also before it would tend to overfit to Curve needs more than actually the global market needs. So we had some strong opinions with Viper and we will see how those have changed across the years, but those are all things that are like not true anymore to some extent. So what is interesting to see here is that like, if you've seen some Viper contracts, they used to be like some big monolithic chunks, so you wouldn't be able to reuse any piece of codes. And this has changed. So it's pretty cool and I'm gonna show you how. We still don't have inheritance, but we have something more explicit, I would say even more secure. And before, since we were very, like Curve used to be very deep into the cypherpunk ethos, and it still is quite a lot, We didn't have any upgradability or proxy patterns. It is now possible, even though we use them with very scarcely. So yeah, this is what Viper looks like. If you will be recognizing for sure some modifiers from Solidity. Something cool is that actually that print statement actually works out of the box. You don't have to import it, and it works on Foundry, Hardhat, whatever. Yeah. This is what an ERC20 transfer looks like. So you have storage variables on top, and then a balance allowance, and then this is nothing crazy if you have ever done smart contracts already. We will see that this is also quite performant compared to the standard for ERC20 tokens on Solidity. Yeah, so we have built-in debugging features like the sprint statement that is literally works out of the box. You have built-in reentrancy guard. This is something really cool, so you don't have to import libraries. It's just already there. And this is new. This is very new. It's a new addition. You have a new pragma non-reentrancy on modifier. And with that one, all the methods in the smart contracts become by default non-reentrant. And if you want to make one reentrant, you actually have to specify that explicitly. So yeah, this here, for example, you can see a create loan function. This is basically non-reentrant by default. But if you want to expose the reentrancy, you have to do it explicitly. And when you do that, actually, it forces you to think, wait, do I actually want that function to be reentrant or not? And I think this is really useful in terms of like security to think about reentrancies correctly, because it's much harder to think about whether it's safe or not to make something reentrant than just the other way around. Yeah, this is also something very, very comfy and cool that Viper offers. So we have this is deposit function from the ERC 4626 standard. And you can see that we have quarks. So this like specifying a default parameter here. And this basically this function here will generate two functions. One that is actually compliant with the standard, and one which is actually more convenient because it defaults to message sender as the receiver. Modules. So this is how we do. This is the Viper answer to inheritance. I like it more, I would say, because it's way more explicit. Like when you're trying to expose something from Viper, like from a Viper module, you really have to go one by one and be very explicit about what you want to expose. There are shortcuts there, but I like to stick to this just because it's basically impossible to make a mistake and everything is basically in the same file. We don't have stack too deep. I think that speaks for itself. I'll just give you a couple seconds to appreciate the meme. And yeah. I just wanted to show you also something very exciting on the Viper side about what is coming. So this is the experimental pipeline for Viper for optimization. The one we have is already pretty good, but this one is even more exciting because here we are comparing SoLady. So if you've ever seen SoLady, it's basically undecipherable Solidity state-of-the-art code in YOL. And here we have Viper. So it's you have to for an ERC20 implementation, you have to imagine that as not too different from what you have seen in the previous slide. So it's really human readable code. It's not inline assembly or was not. So it kind of looks like this. And yeah, if you look at the actual benchmarks, the results are similar, comparable, in some cases even better, just by using the optimization pipeline compared to SoLady token. So this is actually interesting because it allows you to focus more on readability instead of having to optimize for gas. Titanoboa. Who's ever heard of Titanoboa? Yes. Titanoboa is basically our testing tooling for basically test smart contracts, but also to write scripts, like deployment scripts and all sort of things. It's based on PyEVM, which is basically this project from the Ethereum Foundation. And it's the spiritual successor of Brownie. Has anyone ever used Brownie here? No? Okay. But yeah, it basically allows you to build all sort of scripts and tests in Python. And this is where the kind of magic happens, because this tool is so cool because it's developed by the same people that also developed Viper. So you can kind of get things that like it took years for Solidity to have, and they had to write custom compilers and all sort of infrastructure for it. We're going to see more about that. This is how it feels. It's very familiar because, first of all, it's Python, and also because it uses like the cheat codes they would expect, for example, from Foundry, and they're like basically out of the box here, and you can just use Boa. So if you import Boa, and you can do pranks, and you can basically call as if you were someone else, just like you would expect in Foundry. But you also get the convenience of using Python for testing, so you can do things like, I don't know, you want to make a list of 4 people with 25% each, you just do ×4, and it kind of works.
Other examples of things you can do. So this is, for example, how you check whether a function reverse or not. You see, it's very easy to write tests, and you get all the convenience of Python. This is some very cool stuff that we managed to do in Viper that I don't think we have that in any other programming language for smart contracts. So you can do arbitrary evaluations for statements. So literally, this is how you would implement what you would expect with deal in Foundry in Titanoboa. We actually have a built-in implementation, but this is just as an example to show you what the kind of stuff you can do. So you can just add a string to a contract, and this string is going to be evaluated at runtime, and it's going to basically work as if you were injecting code into the Viper contract. So you can do all sorts of black magic with it. It's pretty interesting. Another example of things that you can do, like if you don't have a setter, you just use eval and you set that attribute in storage to the address you want to specify without having to make mock setters and all sorts of things. Yeah. Any questions so far before we dive into this Curve smart contracts? Yes.
Do you support generics for this programming language?
No, not yet. I think there are generics sounds really, really cool on paper. And I wish there was a language that supported them for the EVM. But the reality is Viper still needs a lot more stuff before going into generics. Yeah, not yet. What does Curve build? So across 5 years, Curve has built so much stuff, it's now really hard to keep track. So if you probably have heard of Curve for the first time, it was when it was still only a DEX. So we used to focus on stable coins and yield-bearing assets. That was our initial focus. Then we kind of evolved, and we also supported unpegged assets. So I don't know, BTC, USD, whatever pair you wanted. And we had an interesting approach there compared to Uniswap because we managed to do concentrated liquidity back in the days. We have Lamaland, which is our own CDP. So we also got our own stablecoin, and we have our lending that is primarily aimed at supporting our stablecoin infrastructure. And then we have a bunch of infrastructure. So we have DAO and the fee burning. We're going to get into that later. Yeah. So there's a lot to unpack on the DEX. So first we had StableSwap. So StableSwap kind of looks like this. If you've ever seen it, you basically have this is the liquidity distribution. So you can see how liquidity is distributed across the price for everyone. And this worked really well for stable coins. I remember this was back in the days when the only option was Uniswap V2. So this was a pretty good innovation. And it still is probably our best fitting product so far with a few adjustments because now we have also yield-bearing stable coins and those kind of things. So we wanted to improve the support for that. This is CryptoSwap. CryptoSwap, you have to imagine it's continuous distribution. This is just for visualization purposes. But it's basically stable swap, except it moves around to follow the price. If you are experienced with AMMs, you'll know that this stuff is kind of super dangerous because it's very easy to burn your funds on rebalancing. This is actually where we're quite proud of at Curve because we managed to find a way to use 50% of the cost on average to rebalance and 50% to guarantee us profit for LPs. This is our new version. This is basically a huge Frankenstein we call FX swap. It's basically CryptoSwap, except it uses the same concentration as StableSwap, so very highly concentrated liquidity with the same rebalancing algorithm as CryptoSwap. And the way we managed to make rebalancing so aggressive, this is a CRVUSD BTC pool on yield basis, is that we use a new mechanism we introduced called refueling. I think that would take a whole presentation, so please come talk to us if you're curious about it. And yeah, so let's see. Let's talk a bit about Lamaland. So basically, we wanted to make, our founder had this intuition about a lending market where the collateral is very special. It's not just your ETH. It's not just some BTC. It's not just some classic collateral. It's basically a position that can liquidate itself when the price starts to go down to make the collateral safer by itself. But also, if the price goes back up, it did liquidate itself. So I think that we have a pretty animation. Shout out to our documentation guys at Curve, Mo and Saint, for doing these beautiful pictures. This is basically what happens when the price goes down. You're just paying the liquidation premium because you see the alpha is going down, but your collateral is slowly converted. And when you go back up, so let me show you that again. When you go back up,
actually the price your collateral is reconverted into ETH. So that's some pretty cool stuff we have managed to do, and you can kind of pick your range. So for example, this is for a relatively small range for ETH. And one of the cool things you can do with this is that you can get higher leverage on Llama Lens, because where you can take more risk because the collateral by itself is safer, basically. Yeah, so getting back to it, this is the liquidation protection mechanism is basically the core feature. And at the beginning, we did a CDP mechanism. So you basically put some collateral and you get your own stablecoin. It's called CRVUSD. It's our stablecoin. However, we started also getting a lot of demand for this liquidation protection products, also for more long tail assets, and we couldn't serve it because adding the long tail asset to our CDP would mean basically make the collateral less secure, because your CDP is as secure as your least safe collateral. So this is why we also made a lending market where you could lend CRVUSD and you could borrow against it using more exotic things, of course, in isolation without affecting the composition of CRVUSD as a stablecoin. We have a lot of stuff coming for V2. That again by itself will be another presentation, so please come talk to me if you're curious. So yeah, this is the liquidation protection mechanism that was shown you before. And now we get to the fee burning. So actually the first time I joined Curve, I was a bit naive and I didn't really get it. What was the deal with the fee burning? So fee burning is basically the process where you collect all the fees across all the different pools, Llama Land markets, et cetera, you've made as a protocol, and you want to do something with them. So you either keep them for yourself as a treasury, or in our case, we redistribute the fees to VCRV holders. It sounds like a dumb problem because you could just swap it through a multisig, but the reality is at some point you want to automate it, and also there is kind of some also legal weird situations where you don't really want to be the entity also doing the swaps. It's kind of weird. And the really hard part is that like every single asset that touches Curve has to be supported for this to work properly. So it's kind of tricky if you think about it, because when you have some absurd shitcoin that has entered Curve and you have no clue about it, but it's somehow worth some money, you still have to find a proper place or DEX where it's available to liquidate or not, or you have to decide whether you will never liquidate that position. So after a lot of research, I think we have settled with this very nice solution. So the reality is there's a few chains that make the most revenue for Curve. And on those chains where we're lucky enough to have CowSwap, so we basically built our own infrastructure that does basically automation to burn fees from any asset into CRVUSD, that is our stablecoin, through CowSwap. For those chains where we have minor volumes, we just have a more manual process where we bridge to a chain where it's supported, or we have some auction-based flow on minor deployments. And we do fee burning in CRVUSD, so in this way, it's kind of a mechanism where we self-sustain the peg of our stablecoins. Yeah, we also have a DAO. The DAO has admin over pretty much everything at Curve. It's pretty cool to see it deployed on more than 30 chains, I think, right now. We have the person that had the fund to deploy all the infrastructure on 30 crappier PCs, so shout out to Michael. We did a big bet on storage proofs for cross-chain. So have you guys ever heard of storage proofs? Yeah, so the way storage proofs work, it's pretty interesting. The idea is as long as you manage to bridge, as long as you manage to have on any chain where you want to prove something about the state of Ethereum, you just need to bridge the block cache oracle from mainnet to that chain, and then you're able to prove pretty much anything. So I could prove, for example, if I want to have the DAO cross-chain, I can just execute the vote on Ethereum, and then I just have to get the proof that the vote has passed on the chain, and with the proof, I can basically execute the transaction on the L2. This is an approach that was originally pioneered by Lido because they did a system to bridge their redemption rate through storage proofs, and then we kind of took it and we did a big bet on it. So it's pretty cool because we basically have this kind of public good service where we bridge the block cache oracle on all the chains where we need to have the cross-chain ownership of the DAO. And then we can verify anything about the L1 on all the chains where we are bridging this block cache.
And the cool thing is that right now we have built this in a way where it's cross-chain provider agnostic, so you could use any message passing technology, and we don't have any vendor lock-in. So right now we're using layer 0 because it's probably the most convenient so far, but we are not vendor locked. So in a way we can always switch to a better message provider if the time comes. This is pretty exciting. It's a small thing I built in a couple days, but it's to kind of highlight how powerful TitanoBoa is. So this is built entirely on top of TitanoBoa without having to fork the library. It leverages the Python runtime execution plus the patchability of PyEVM. And yeah, you can do cross-chain votes, you can do all sorts of stuff. So this kind of thin Python wrapper using TitanoBoa to interact with the Aragon contracts. And what I really like about it is how simple it is to express votes for the DAO, and how readable it also makes it for contributor to verify. So you can see here, for example, this is a script. So I'm forking Ethereum mainnet. This is an example where I'm trying to change the admin of a factory. So what I do is I get the factory from Etherscan, so it downloads the API, all the information I need, and then I can just basically set the new admin. I make a description for the vote. So I'm just updating the admin for this factory to this address. And then you just use this context manager vote, which we built. And it's kind of interesting because it's kind of a little thing we've built, but we have so many examples of this in the Curve infrastructure just to support our workflows, because we really went for a different approach. But somehow we always get some advantages or some learnings from it because we really own the stack. And then you can see here, so the vote context manager literally takes the description, the ownership DAO, because we have one DAO for ownership of parameters and the other for one for ownership related votes and one for parameters related votes with different quorums. So it's a small detail, but you have to specify that. But the cool part here is in the context manager, you can specify the change you want to do on chain, but you can also do assertions about things like you want to actually verify that the vote is executed correctly. So for example, here the admin has to be set to the new admin. And the context manager is smart enough to recognize what is a static call and what is an external call. So if the vote is changing the state of the chain, it will be added to the payload like this one, but the assertion is ignored. So you don't have to think about testing later. You can literally inline everything. And we have plenty of examples of infrastructure like this at Curve. So our direction. And this is where it gets interesting. So far, I think there's a general direction of de-optimization because I think we have seen it with the recent hacks. The reality is it's much better to be readability maxi and to go all in on trying to have our code as secure as possible than to save a few cents. Also, I'm not trying to blame anyone here. Like back in the days, the gas on mainnet was way higher. So there was actually some interest in optimizing, but right now we're going in a direction where it's getting cheaper and cheaper to have execution. Modularization and unification. So let's go through it. This is the kind of stuff we would do before. So what is funny here is that there's a variable called old virtual price, but actually if you read the comment carefully, calculate new virtual price using reuse old virtual price, but it does new virtual price. This is the kind of stuff we do, plus unsafe divisions all over the place, and you also have to specify why unsafe division, and basically one line that is technically very simple becomes really hard to read. Modularization, because as I said, it's a recent thing that Viper actually has modules and we can leverage fully code reuse. So we have a lot of code in production that does not leverage code reuse, and we want to change that because this way we have to test way less code and we can be leaner in execution and shipping. So SnakeMate is, shout out to Pascal, is a library built by Pascal, who's an amazing contributor at CEO. And yeah, we're using a lot of this library and we get it audited whenever we can. We are building our own Sonar library with our own building pieces that anyone can actually use. So please come take a look. It's going to get bigger and bigger over time. And we're trying to reduce code duplication because before, literally, like so many pieces of the infrastructure were just duplicated across parts, and it's literally unsafe from an engineering point of view because it's so easy to make mistakes when you have different repositories containing the same stuff. And you also have to like copy paste tests around. It gets messy, it gets dirty. So this is everything that we're changing. But again, it's kind of this interesting part where like as Curve and Viper have like grown together, it's like we're also getting too mature together. But the unification, the reality is, yes, we have to be careful not to fall into this category, you know, the thing where like you unify everything and the reality is you have a new pool standard that people have to support. This is kind of tricky and I try to avoid the situation as much as possible. But the reality is right now, for example, let's take our pools.
we have 3 different pools that we want to support, that you want to support if you're an aggregator, arbitrager, whatever, plus a bunch of legacy pools. There is not much we can do about the legacy pools. Those fall more into the 14 competing standards category. But for the new upcoming pools, what we can do is unify those 3 pools on the same interface, which is not the case right now. Because the reality is I want to see this kind of memes disappear. This was actually on stage. I don't remember who that was, but the point is, I don't know if you can read from here, but it kind of says, let's integrate curve. The pseudo maneuver is going to cost us 51 years. This is real memes by real developers that hate us so much for this. So hopefully the goal is to get to a point where you have to support at least one to future-proof yourself, one interface to future-proof yourself. And all the old ones are already competitive enough and supported by enough people for you not to care about it. Hopefully, in an ideal world. So thanks a lot for listening. And if you have any questions, I'm happy to answer it.
Cooper is going to give us a deep dive into the custom liquidity curves with Doppler. Doppler is an EVM-based smart contract protocol for customizable token launches. Please welcome Cooper.
Thank you, sir. Hello, everybody. My name is Cooper. I'm on the team at Whetstone Research. I technically am the head of product, but I like to joke that I'm Austin's personal assistant in various ways. And yeah, we're going to talk today about Doppler and custom liquidity curves. Quick overview about Whetstone Research, founded in 2024 by Austin Adams. He used to work at Uniswap. He was a co-author on UniV3 and V4. Our early hires used to work at Primitive Finance. If anyone's familiar with Primitive Finance, they used to work on an RMM or a replicated market maker. In 2024, we announced our pre-seed funding led by Variant. I was actually an investment partner at Variant when this happened, and that's how I met Austin. And our current team is about 10 people, so it's pretty small. I'm actually the least technical person on the team, which is kind of nice. We currently have 2 products that we build at Whetstone Research. We build a protocol called Doppler. We have a kind of cool website. It's doppler.lol. We jokingly say that LOL stands for liquidity online, and we're definitely in the business of bringing liquidity online. Doppler is a protocol for custom markets for launching tokens. We'll talk about what that means. It's available today on Base, Inc, Unichain. We'll be live on Monad next week on day 1. We also have an interface that's called Pure Markets or Pure Street. You can go to pure.st right now and Pure basically currently is an aggregator for all tokens that are made with Doppler. And you can actually easily launch your own tokens on Doppler in just a few clicks. It also has free swaps across all of these. And so we'll talk a little bit more about this. But Whetstone Research is fundamentally a research firm from the people who designed Uniswap and Primitive Finance's RMM. And we currently build 2 products. And so about Doppler. Doppler generally is a system of smart contract, what we call modules that can all be used together, and they should be used together. Doppler has what we call an airlock contract that coordinates the deployment of all of these other modules. So when you interact with Doppler, you only interact with the airlock contract. You don't have to touch any of the other modules directly. The airlock will manage passing all the downstream parameter configurations, setup, whatever. Here's the types of modules that are available in Doppler. So we have token factories. You can have your own custom token factories that we'll talk about, but you basically create tokens that map to the DERC20 interface. We also have governance factories. We can automatically create on-chain token holder governance for you with these tokens. We have different types of pool initializers. We'll talk about what that means, but different ways to create new liquidity pools. We have bundlers, which basically let you pre-buy tokens at the time of token creation before anyone else can get to it, so you can get guaranteed allocation without sniping. And we also have liquidity migrators that can migrate the generated liquidity to other AMMs or other pools. And so by calling the Doppler airlock, depending on your configuration, you're going to be calling downstream contracts that deploy tokens, that deploy governance factories, that deploy different LP pools, that actually bundle buys at the same time as your tokens get created and migrate liquidity into other long-term AMMs. Importantly, one of the most differentiating things about Doppler is it's for customizable token launches, and it's a customizable smart contract protocol. And what we mean by that is other teams can build their own modules, their own smart contracts, and add them to the Doppler airlock. There's a whitelisted set of modules that you can use, and you can add this to the airlock, and you can call the airlock and have basically shared standards with everyone, but also your own customization and differentiation. We'll talk a little bit more about how teams are building custom modules today, but that way you can actually have 90% of the token ecosystem can be cohesive. It can use the same standards. It can use the same indexing solutions. But you can actually still have differentiated tokens and launches. Just quickly to talk about users, Zora uses us for content and creator coins. We power all of Zora's markets. That means we're also integrated in the base app. So, the base app uses Zora. Paragraph uses us for content and writer coins. Coop Records is using us for song coins. FX Haster is using us for artist coins. O'Hara is an AI prompt application that you generate prompted apps and it'll make coins for them. Long is using us to launch product coins as well. Noise recently went live and is also doing product coins and fundraising. You can view all of these integrations on Pure, and you can trade all the coins that are made from any of these applications. So we aggregate all the Zora markets. And so, yeah, that's kind of an overview of like what we're doing, kind of setting the stage. Let's talk a little bit about more what like makes Doppler kind of interesting. And fundamentally, it is a liquidity bootstrapping auction. We currently support 3 different auction types, and they can all be customized in different ways. We have static auctions, which you can imagine is just a traditional bonding curve. It is a single price curve, and it doesn't change. It's just a static price curve. This is really, really interesting because it basically provides, a pump.fun style experience, but it's not one size fits all. You can pass in any parameters that you want and get any type of arbitrary price curves. This is important because the Doppler static auction is built on top of Uniswap v3 and is available on any network that actually has Uniswap v3 or can be deployed there. Probably the most interesting product that we offer is a dynamic auction. This is a real-time on-chain Dutch/English auction that'll respond based on market demand. And you can actually parameterize like the price deltas in between ticks and how drastically the curve's going to decay or go up based on relative purchase demand. It's the first on-chain fully Dutch and English auction that was ever shipped to production. And so you can basically start a token at $10 million. You can say that I want it to go down and decay down to $1 million. And you can actually define the curvature, the gamma value at which it will do the decaying or go up in value. The dynamic auction is very much optimized for how do you sell the least amount of tokens at the best possible price. So it will try to get you the most money out of your token sale as possible based on all on-chain market data. This is what we have the original Doppler white paper on. This is what like the original kind of thesis of the company was, is that we're going to move from static and traditional bonding curves into real-time on-chain auctions that actually respond to market demand. We also have a product that's called multi-curve. This is the most recent auction that we shipped, which lets you place multiple positions or nest different price curves on top of each other. So you can imagine a single bonding curve, but you can imagine placing 10, 20, 50 of them that overlap with each other depending on how you actually want to granularly manage liquidity. And so this is a really specific way that you can granularly manage, like let's say you want to sell 10% of your token supply between $1 and $10 million. You want to sell 30% between 10 million and 50 million, and so on and so forth. You can place very specific curvatures. We also have a white paper for this. This was co-authored with the Zora team, and this is what Zora currently uses in production. And it lets you auction tokens off at any price. You can pass them in as input parameters to the airlock, and it'll, like from the airlock, you can call all 3 of these auctions. You can pass in the initial market prices. You can also pair tokens with anything. So Zora pairs all their tokens within the Zora coins, and they have a nested flywheel of economics. But so it doesn't just have to be ETH or USDC. You can create arbitrary token pairs. And so if you go into the base app, this is how the base app is doing like content and creator coins, where they have a creator coin for every social profile, and every post you made is paired with your actual profile coin. So you can create a kind of cohesive set of indexes. And then auction proceeds by default are used to seed DEX liquidity. You don't make money. When you sell tokens on Doppler, you're not directly profiting. You don't take that money as revenue. You don't doesn't go to a multi-sig anywhere. The proceeds from the auction are used to seed DEX liquidity and build an actual ecosystem that's sustainable. You can build custom migrators if you wanted to keep a percentage of your auction proceeds that, basically acts as revenue or fundraising. But by default, Doppler only generates proceeds to put into liquidity pools. This slide does not want to change. So just like a quick overview of the V4 dynamic auction. So V4 is called V4 because it's built on top of Uniswap v4. It was the first auction software built on Uniswap v4. Austin actually started designing a lot of these auctions when he was working at Uniswap and was writing the Uniswap v4 paper. The kind of TLDR is that we have before and after swap events that'll rebalance the liquidity that's being placed in each position. So the whole positions are not placed ahead of time, but based on the amount of market demand, buying interest that you have relative to the last epoch, which is configurable, it'll rebalance all of the positions. And so if there's no purchasing demand in the last epoch, and let's say the last epoch's 10 blocks, it'll actually do a Dutch auction based off your epoch duration and have the next block have a lower price liquidity. And so it'll decay and decay and decay until it finds the right market price in which people are willing to bid. And then it'll continuously try to go up with a new bonding curve. And so the epoch length, the gamma values, which is like the deltas in which how fast it'll change tick pricing, are all configurable and parameterizable. The V4 dynamic auction from Doppler is probably one of the best documented and audited Uniswap V4 hooks that's out there. If you are building Uniswap V4 hooks, we highly recommend taking a look at it. And yeah, let's talk a little bit about liquidity migration and what that means. So we have these auctions that generate liquidity in this token sale, and basically use the proceeds that are generated in that auction to migrate it somewhere else. And these are configurable at the time of creation. And with static and multi-curve auctions, you basically specify the proceeds target that needs to be generated at creation time. So if you want to generate 10 ETH, you pass that into the airlock, and as soon as it hits 10 ETH in proceeds, it'll migrate that liquidity to wherever you want. And you can migrate liquidity to Uniswap V2, V4, or don't migrate your liquidity at all. If you do an auction in a V3 pool or a V4 pool, you can leave it and have one single continuous price chart. Or you might want a different price chart for the price discovery and auction period than you would have for the actual like long-term AMM. You might also want to have different fees in the auction than you would for long-term sustainable AMMs. And so you would want to potentially configure these differently. And then with dynamic auctions, you specify a min and max proceeds, which is the minimum or maximum amount that you'd like to raise in the auction. And if max proceeds is reached, you migrate the liquidity immediately. If min proceeds is not reached by the end of the auction duration, we only allow refunds. So you usually get an average price swapping out of the pool, but you can't buy it into the pool anymore. And we will support where you can build custom migrators. So we build and have developed and have audited, the Uniswap V2, V4 migrators. Teams have built other migrators that migrate to more centralized or, not publicly accessible AMMs, like whitelisted ones. You could also build migrators that go to other AMMs like Aerodrome or, any AMM that you're like excited about. And it's super, super easy to configure these things. It's just like a one-line change of code. If you want to migrate to V2, you just type in V2. Migrate to V4, you just type in V4. If you don't want to migrate liquidity, you can just type in no op migration. And yeah, we'll talk a little bit more about how you can use these things, but we make it really, really easy. You don't have to deal with any auction complexity. You can just write TypeScript. We have a bunch of other features. So we have governance. You can optionally create tokens with Governor Bravo treasuries. You could build your own governance factory as well if you wanted to use something else. We have vesting out of the box, and so you can basically specify different percentages of your pie chart that'll vest over time and unlock. Zora, for instance, gives the creators of content coins or 50% of the token supply, but it's vested over 5 years. So it's a really long-term kind of sustainable model. We also support inflation, and you can specify like yearly mint rates, so you don't have to have a fixed asset. We're working on a bunch of other things soon. I would say that we take a very customer-driven approach to how we develop modules. And so if a customer comes to us and says that they want a specific module that does whatever the hell it is, we're happy to build it for you or with you and make sure that it's supported. Talking a little bit about fees and economics of the protocol. Slide does not want to load. Oh, I think my little animations are fucked up. Yeah, so fees and beneficiaries and quantities are defined at the time of creation. You can basically add an arbitrary amount of addresses that are going to earn on every single swap in this pool. And so that can be in the auction phase or that could be in the post-auction migration phase. And you can add multiple fees and multiple beneficiaries with Uniswap V2 migration. Uniswap V2 has this nice feature where the fees can actually rehypothecate into liquidity themselves. And so a lot of the early Zora pools were made with a V4 auction that migrated into Uniswap V2. And so the liquidity in those pools will actually grow over time based on volume and trading volume. And so it's a really nice way that you have sustainable liquidity. A lot of the early Zora coins actually have like a 1-to-2 liquidity to market cap ratio, which is kind of crazy. We also are currently working on buyback and burn and other what we would probably consider portfolio management strategies that you would be able to also call from the Doppler airlock. If you don't want to just have liquidity grow over time, but you want to actually be burning a percentage of your token, you'll be able to do that as well. And our business model is basically that we have an enshrined protocol fee of 5%. We take 5% of whatever our customers choose to charge. And so if, our customers choose to charge no fees, we don't make any money. If they choose to charge 10%, we're going to make 5% of their 10%. And so we only really make money when our customers make money. And this is what the minimum kind of viable multi-curve launch. Most of our customers are consolidating on multi-curve right now instead of the V4 auction. Multi-curve is a strict improvement over V3 in the static auction because you could do a static single curve auction with multi-curve by placing just one specific curve. And so there's, if you have V4 support on your network, there's no reason not to use multi-curve. So almost all of our customers are using multi-curve right now. We do think that the dynamic auction is objectively a better, more capitally efficient product, but it's really counterintuitive for traders. Traders don't expect to have to time their trades against market demand and all these other externalities. So no one's really figured out the user experience for a real-time dynamic Dutch auction on chain yet. I think that you could slow it down and it could be a little bit more perceivable, but the whole goal is real-time capital discovery, and that's not very intuitive for most traders. So you can see here, you basically just pass in a token config. You can pass in the name, the URI, whatever. You can pass in the sale config. You can have as many tokens as you want. You can sell, you basically define how many tokens are available for sale on the auction. The numeraire is what asset your token's paired with. So this is WETH, or you could use USDC. You could pass in any arbitrary asset as the numeraire. And you can see that we have a builder pattern. So it says with multi-curve auction. The multi-curve, we also, basically the same thing. You do a token sale config, and then you would do with dynamic auction or with static auction, depending on which of the auction types that you want. And you can see in this case, we're setting 0 fees. Tick spacing is just under the hood Uniswap. You don't usually have to edit the tick spacing unless you know what you're doing. And then this is actually how you define all your price curves. So this first curve starts at 0 and would go up to 240,000 ticks, which actually probably is an invalid number, but you can play around with them. And basically you can add as many curves to this structure as you want at any arbitrary ticks or arbitrary market caps. And you can define how much of the token supply that's to sell is allocated to each of these curves. So in this case, we have 2 curves. Each of them is allocated 50% of the 9,000 tokens available to sell in this auction. And just for simplicity's sake, it defaults to no-op governance, which means that there's not going to be any token holder governance for this. It defaults to no-op migration, which means that the Uniswap v4 pool that this token's auctioned off in will always be the pool that it exists in. It'll always be the canonical pool. It's not going to go anywhere. And then, your user address. And so this is actually like 10 lines of code. It's almost all that's necessary to configure a multi-curve auction with Doppler. And we try to abstract away, all the complexity of doing Uniswap math and integrating with DEXs. Our SDK also supports quoting and swapping and routing, and we do multi-hop routing through different niche assets. So you can imagine these Zora coins that just are newly created might not have a lot of liquidity. And so we do provide custom routing and quoting support for these tokens. So this is basically what it looks like to interact with Doppler. 10 lines of code, you can get a custom market. If you wanted to build your own launch pad or something like that, it could take you like months and months and a lot of money in auditing to actually just do a simple token launch. And so just to talk about a few examples here, these are Zora creator coins, and you can see actually the price curves that were defined with Doppler. Balaji was one of the earliest Zora creator coins that was made. And you can actually see in the liquidity things from Uniswap's app where you actually have the first price curve that they set and then the second price curve. And we're constantly adjusting and updating these markets, right? You can update these on the fly with dynamic values. And so Zora is updating their markets maybe once a week, maybe even more frequently than that. And they're going to eventually move to potentially a dynamic model where every single creator or post is going to have different input parameters based on publicly available data. So if you connect your Twitter and you have millions of followers, you should probably get a different liquidity curve than someone who doesn't have any clout. Like, you're just going to have different sniping risks. Your token's inherently more valuable. And so the way that markets change are not going to be these statically priced or statically launched things. They're going to be dynamic. And so for song coins, like Coop Records has San Holo and like Barry Can't Swim launching song coins for like notable DJs. But if Drake comes on and launches a song coin on Coop Records, like he's going to get a very different price curve because his market's just not the same. And we make it as easy as like 3 lines of code. And you can do this on the fly on demand. Like every single time someone goes to your app, you can be passing in different price curves. And so you can see that Balaji was one of the first coins. Zora TV is a more recent coin. And you can actually see the difference in the way that they're structuring their price curves very obviously. Like they're very much trying to sell a very, very small amount of liquidity early here. And then they want it to ramp up, and they think that this is probably all sniping demand. And so this is probably priced very differently than this price curve here. And you could do this arbitrary amounts of times. You could do this 10, 50, 100 different price curves. This is a little bit more specific of an example, but Noise is a team building on Base. They just launched on us last week. And this is how they actually very specifically structured their price curves within multi-curve. So they have curve 0, which is basically a team buying 10% of the total token supply. And they're buying it at around 200 to 250K price. And that gives them a well-defined cost basis for taxes and other things, rather than granting it to yourself. But then they're placing about, 5 different curves along their growth. So they're selling 4 billion tokens between 250,000 and $1 million. They're selling 6 billion tokens between $500,000 and $1 million. And you can see that curve 1 and 1A and 1B actually overlap with each other. And so you get very specific liquidity management. With curve 2, they're selling 1.5 billion tokens at $1 to $2 million. Curve 2B again overlaps with 2A, and they're selling another 1.5 billion at $1.5 to $2 million. And you can see that they really think that these token launches should exist within this range of $250,000 to $2.2 million or so. That's where a majority of the liquidity is in, and they think that that's where a majority of the price action and trading volume should happen. Based on these specific configurations, at a $2 million market cap, these tokens should have somewhere around $600,000 to $750,000 of liquidity, which is actually like a really good liquidity to market cap ratio. And then you can see that curve 3, they basically have a long tail, and this is kind of a default pattern, is like after your curve ends or like after the specific price ranges that you want to sell tokens in, you set up a long tail position. And so they allocate the rest of the token supply from 2 million all the way up to $1.5 billion. They think that there's still interest in a long tail position at $1.5 billion, which is like them kind of saying, we think something's going to be worth $1.5 billion on Noise someday, which is pretty exciting. You can learn more on docs.noise. They're very thoughtful about this and are actively looking for other teams to launch on their launchpad. It's permission, so you have to apply and stuff like that. But they recently launched Oracle. It was their first launch, and they're going to continue doing more. But this is a really good example of how granularly you can create custom markets with multi-curve. You could keep doing this. Every single person or every single product could have different price curves. You could imagine setting these up based on your previous fundraising, or you could structure this very much like you're selling equity or access to your cap table. You could sell a pre-seed round up to $10 million. You could sell a seed round up to 250 million, whatever it wants to be. You could structure your liquidity distribution accordingly. And that's all that I have today, which was a lot of me talking. We have websites for Whetstone, Doppler, and Pure. We have 2 white papers for both the dynamic auction and for multi-curve. Our docs are available at docs.doppler.lol. We have an open source TypeScript SDK and indexer that's ready to use off the shelf, and we're very hands-on integrating this with teams. All of our code is open source on GitHub, including all the smart contracts, the indexer. We have a demo application that you can run that supports all the different auction types. We've had teams just take our demo application, throw it into Claude, and actually yeet that straight to production, which is kind of crazy. But it's very efficient. We've seen teams turn around deployments within as little as 3 days. I would say usually integrations take somewhere between 2 to 4 weeks. But we have seen teams go from 0 to production in as little as 3 days. And then, we have a Discord. We're pretty active in there. We also have a Telegram. But happy to answer any questions. And thank you, Fenbushi, for hosting.
All right, that is it for us today. The whole day, all of the speeches, all of the panel, everything will be available at Fenbushi's Twitter, which is at Fenbushi, and also on Fenbushi's YouTube channel. So if you want to watch anything or rewatch or catch up or whatever, please feel free to visit. Thank you so much.